Hide the planet! Hide the planet! Shut up again!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. Looks like... What is up with my avatar? Just a second. Let's see if we can get that going. Gonna have to restart my program. Just a second. I love technical difficulties. Okay, and then we'll restart the avatar. Okay, we're back. Well, hopefully we're back. Let's see if it shows up on stream. Here we go. Okay, so this is HackerFrogs AfterSchool. Hello, I'm the Shy Hat, and we're going to be doing 4 things up in this stream. What are we doing today? So it is Variety Fridays, and we're going to be doing a new topic for the first thing we're doing in this stream. It's going to be HackerFrogs Cybersecurity News of the Week. We're going to be taking a look at some news stories. Gameboy, hello, nice to see you here. Nice to see you here on YouTube. And yeah, that's the first thing we're going to be doing. We're going to be going through some news stories that happened in the last couple of weeks, and then we're going to be doing HackerFrogs After School. This is going to be our educational series on how to use Linux. So that's going to be in the second hour, and in the third hour, we're going to be doing some reverse engineering. For some reason, we got Nightmare here. It's not actually Nightmare. It is going to be MicroCorruption. So MicroCorruption is a website where you can learn about reverse engineering through using it is some sort of assembly language. I'm not exactly sure which one it is, but we're going to be going over it, and we're going to be learning more about low-level programming. And Tufasho, nice to see you here. Welcome to the stream. Okay, so the last thing we're going to be doing today is we're going to be doing some binary hacking. So binary hacking and reverse engineering, it's going to be these software hacking challenges from the OLIcyber.it website. So that is an Italian CTF platform where we're going to be solving some cybersecurity challenges. So that's going to be the 4th topic of the day. And without further ado, let's get into the news. I'm going to put... Let's see. Gameboy says, did you hear about the new hybrid Petya ransomware? Bypasses UEFI secure boot. Okay. If it's a new hack, why does the CVE say 2024? I'm a bit confused about that. But you know what? Let's see. We might have some time to talk about that a little bit later. I'll just keep it in my Google. Okay, so let's put 60 minutes on the clock. We may or may not use the entire 60 minutes, but let's go ahead and put those 60 minutes on the clock. We're doing topic number 1. Topic number 1 is cybersecurity news for September 12th, 2025, and the second topic is on deck. It is HackerFrogs After School session 3 of 5 for Linux OS. All right, so let's get started. So the first thing we're going to be taking a look at is the RBI Burger King hack. So RBI Burger King, and well, the source for this is a podcast that I often listen to. It's called Smashing Security, and if you want to take a look at the podcast episode yourself, you can over at this link over here. So we're taking a look at this news story right here, and it says, "We hacked Burger King, how authentication bypass led to drive-through audio surveillance." So this is something from the Wayback Machine, and we're just going to navigate to the website. And this URL has been excluded from the Wayback Machine. Okay, so it looks like they've taken that down. That's unfortunate. So let's see. But I guess we could do a little bit of manual searching for this as well. So RBI Burger King hack. So Burger King hacked, ethical hackers crack fast food. So let's talk about this. All right, we'll read through the article and then we'll talk about this. If you have any comments or questions about any of this stuff, feel free to leave it in the chat. Okay, so we're talking about the parent company of Burger King, and let's see. Restaurant Brands International, RBI, the parent company of Burger King, Tim Hortons, and Popeyes, has been called out for glaring security flaws. Two ethical hackers known as Bob the Hacker and Bob the Shoplifter recently revealed how easily they gain access to critical systems. Their findings... Leet IT WizKid, hello, nice to see you here. Welcome to the stream. We're just doing a little bit of cybersecurity news stuff. And we're talking about how Burger King got hacked. So let's see. So Bob the Hacker and Bob the Shoplifter recently revealed how easily they got access to the systems. Their findings, now archived after the original blog was pulled, paints a troubling picture of fast food cybersecurity. Well, I mean, I didn't really guess that fast food companies would have really great cybersecurity, but let's see. So passwords that anyone could guess. One of the most startling discoveries was a password hard-coded into the HTML of an equipment ordering website. So this is the type of thing that you see on easy web app security challenges, where the password is in the comments of the HTML. So this alone would have raised red flags, but the issues went further. In the drive-through tablet system, the password was simply admin. Okay, so they left default passwords, it looks like, or that's kind of embarrassing. So weak credentials like this are usually caught by even the most basic antivirus checks and system audits. For a global company running over 30,000 outlets, such oversights raise serious questions about how little attention is given to digital safeguards. Gameboy says they have the same security as schools. Kind of, yeah. So the hackers explained how they accessed employee accounts, internal configurations, and even raw audio recordings of drive-through conversations. So this is one of the funny things that I caught on when they were talking about it on Smashing Security. Leet IT WizKid says, where's the binary hacks? So the binary hacks are coming on later in the stream. It's probably going to be happening in about 2 hours or so. So if you want to come back in about 2 hours, we're going to start talking about binary hacking. Well, we're first going to start talking about reverse engineering and low-level programming, and the binary hacking stuff is going to be in about 3 hours or so. So if you're looking specifically for that, then that's when it's happening. So these recordings, yeah. So they record raw audio conversations of the customers who come up to the drive-through. So I guess this is for some sort of analysis, but it's actually pretty creepy. So these recordings sometimes contain personal information such as customers ordered food, which is later processed by AI systems to evaluate both staff and customers. So this access, while responsibly handled by the ethical hackers, highlights what could have happened in the wrong hands. Okay, so the exposure extended to odd corners of the business as well. The team uncovered code tied to restaurant bathroom rating screens. So does that mean that you can rate the bathroom remotely? It doesn't really say whether or not that's something you could do, but it seems kind of suspicious. Although they joked about leaving fake reviews from home, they stuck to responsible disclosure practices. So they stressed that no customer data was retained, but the scope of their findings shows how open the systems were. So the ethical hackers described RBI security as catastrophic and solid as a paper whopper wrapper in the rain. That language may be tongue-in-cheek, but the flaws were real. So they included an API that anybody could sign up to without restrictions, and plain text emails containing passwords. So this is, this is a nightmare scenario for people who would be able to get into the inside. Well, I mean, we don't even know if you needed to get inside the network before you saw this stuff. So that's pretty bad. The duo even found ways to grant themselves admin access across platforms. These are problems that basic ransomware protection and good malware removal policies are meant to reduce. Yet the report shows that security fundamentals were overlooked at a corporate level, leaving every associated brand at risk. RBI reportedly fixed the issues once informed, but the company did not publicly acknowledge the ethical hackers. So, anyways, that silence leaves open the question of whether or not the lessons will be truly learned or if this was treated as a patch and move on event. Okay, well, that's unfortunate that the company that owns Burger King has such shoddy security, but let's move on to the next story because we got quite a few stories to cover today. And what's the next one? So the next one is going to be Cybersecurity braces for AI attack. Okay, so this one is from Axios. And if you're wondering what we're looking at, this is the article we're looking at right over here. Okay, so let's see. One big thing, cyber industry braces for AI attacks. So bad actors are close, using AI to hijack other AI systems that companies rely on, like chatbots or agents, forcing them to go rogue, warns John Waters, a longtime cybersecurity leader, and former top executive at Google's Mandiant. So Mandiant is a big deal, yeah. Why it matters. The world is only months away from an untraceable cyber attack run entirely by an autonomous AI agent, Waters says. Sarah, hello, nice to see you here. We're just going over the news. So if you want to take a look at the news stories we're covering today, here's a link. So he says that attacks won't be generic. It will be built uniquely for its victim, exploiting a zero-day vulnerability tailored to that company's systems. The big picture. Security vendors need to adapt faster than ever to prepare customers for the new reality. I mean, we've been hearing about AI tools being used for hacking for quite a while now. We haven't really had a lot of mainstream exposure of it happening out in the wild. Frackery, hello, nice to see you here. So that means we won't need to recycle old techniques or turn flaws into widely used enterprise software to get the most impact. Instead, each strike will employ a one-of-a-kind weakness in a company with little to no effort. When they say little to no effort, that seems kind of like hyperbole to me, because if you're counting on the AI to find 0 days to use in your really big cybersecurity attacks, I don't think it's necessarily going to be that easy. Sarah says, I thought it was Axios, the JavaScript library. No, not necessarily the JavaScript library in this case. So we're talking about a website called Axios. So reality check. Waters is now the CEO of iCounter, a startup building products aimed squarely at the threat. So he's not exactly a neutral observer. Okay, so let's see. Waters expects rivals to emerge by next spring. So I guess he says that it's not happening right now, but it's going to be happening in about 4 to 6 months. Okay. So what is at the end of the RSA conference, 2026 RSA conference? What? Expect the term AIDR, AI detection and response, to dominate the trade show floor, he says. So he's making a prediction for the next RSA conference. Think of AIDR as a play on the current suite of endpoint detection and response tools. However, instead of monitoring network endpoints, the AIDR products focus on spotting when adversaries hijack an organization's AI tools, which he says will have a huge target on their back since they will have been overtaken and forced to hallucinate or go rogue. So they're imagining that people are going to hack into company networks and then take over their AI systems, and then maybe use those systems to facilitate the hacking of the rest of the network or something. I'm not exactly sure, but let me turn on the music. Music isn't going to be super loud. Make it a little bit softer. Okay. I don't like just having my voice as the audio. makes me a little self-conscious. Okay, so recent breaches of Salesforce's AI agent underscores the point. Major security companies like Dynatrace, Qualys, CyberArk, and Cato Networks are among the latest victims. What they're saying. So the security gap is the difference between the innovation pace of the adversary and the innovation pace of the defenders. Adversaries lead. We all think we're innovators. We're not. So, I mean, this is all very alarmist. I don't know whether or not these are going to come true, or at least I'm not sure if they're going to come true as quickly as this person is expecting they're going to be. Okay, so between the lines, Gartner projects that by 2028, 70% of all AI implementations across threat detection and incident response will involve multi-agent AI, up from 5% of the report's publication in March. That's a pretty big jump, 5% to 70%. Okay, Waters expects these tools to drive the conversation at RSAC, but the 6 months until the conference in San Francisco next year is still several lifetimes away in terms of AI development. I mean, we have seen that AI is developing at a pretty quick rate, but we're not seeing too much as far as the agentic AI that is supposed to be taking over this year, like it was predicted last year. Okay, so this is some fun over here. ChatGPT is crushing the competition, so we're talking about monthly visits to AI platforms. I took a little look at this earlier, but it looks like ChatGPT is the most popular one, with, what is it, nearly 6 million? 6 billion. Huh. 6 billion visits to ChatGPT as opposed to 750 million for Gemini, 630 million for DeepSeek, 210 million for Grok. Character AI is this popular? It's more popular than Grok even. Claude AI is not. These other platforms don't seem quite as popular when compared to other ones. I mean, I use ChatGPT, I use Claude, and I have used Gemini before, and DeepSeek as well. But it's actually really surprising that DeepSeek is so popular. It's number 3 compared to all the other platforms here. But yeah. So ChatGPT is the most popular one. Okay. AI set to upend search and advertising model. Okay. And let's see, training data plus this. All right. So that's about it for this story. Let's move on to the next one. So the next story we're going to be covering is AI created annoying CAPTCHAs. So if you've ever dealt with CAPTCHAs before, this was another story from Smashing Security. And Smashing Security is, well, it is one of my favorite it's one of my favorite cybersecurity podcasts. So this is from the same episode. They talk about, where is it? Ethan Mollick's terrible AI CAPTCHAs, AI-generated CAPTCHAs. Gameboy says, nice, you finally made Discord. Yeah, after people harassed me about making Discord, I eventually gave in. Okay, so what do we have for this post? I have a new terrible test of AI ability. Create and execute the most annoying functional CAPTCHA in the world. Really go all out. Okay, and we've got Gemini. So this is Gemini coming up with the most annoying CAPTCHA. Okay, I mean, is there a link to try this out? Because if there were, this would be really funny. I guess it's just a picture. Okay. And let's see. Let me see if I can search this up a little more. Terrible AI generated CAPTCHAs. Terrible AI generated Okay, so let's see. Getting ridiculous CAPTCHAs images created by AI. I think I really want to test this out because CAPTCHA is becoming useless as AI gets smarter. Okay, let's include the name of the person who made the post. Ethan Malik. Okay, let's see if I can type that out. Okay. So this is from a week ago. And there's a blog article. I think the blog article is going to give us better results. What do we got? So a lot has happened in the past week or so. I wanted to write a post taking a stock of where we are. Okay. Brains. When do we talk about the horrible CAPTCHAs? I guess we don't. All right, let's find another thing. Annoying CAPTCHA tests, Claude Opus challenge. Let's take a look at this one. Okay, so it looks like we've got a video. I have a new terrible AI test of AI ability. Create and execute the most annoying functional CAPTCHA in the world. Really go all out. So let's see. Claude 4.1 Opus created this nightmare. I couldn't get past level 2, so I had to ask it to create a skip button so I could see all 9 circles of CAPTCHA hell, as it called them. Okay, you can try it here if you like the pain. So this is what I'm looking for. I'm looking for the ability to try this out. Okay, so yeah, because this is an external link, we're unable to verify it for safety. We'll try it out because this is a virtual machine working with right now. Oh wow, this hurts. This really hurts. Okay, so check the box below to continue, but don't check it too fast or too slow. Click me. Oh no. I gotta click the thing. This is giving me a headache. Okay, I'm gonna skip this one. Okay, set the slider to exactly 42.7%. You have 3 seconds. 42.7. .7. Okay, I hate this. I hate this. Okay, solve the simple math problem. Calculator use equals instant fail. I can't. So do we need to? Oh wow, we can't type. Can we type? We can type. Okay, all right, let's move on to the next level. Memorize the sequence in 2 seconds. Okay, 5PELH. All right, we'll skip this one. What's the next level? Click all the green squares in order from 1 to 10. They turn red when you hover. They turn red when you hover. 1. Okay, so let's skip to level 7. Okay, level 7. Type the opposite of what you see below. Yes means no, up means down. So we type small. Uh-oh. Okay. I don't want to do this anymore. The flashing lights are giving me a headache. Anyways, let's get out of here. All right. Well, that was a news story. Sure, why not? Let's move on to the next thing. What is the next news story? Okay, an NPM supply chain attack. So I'm interested in this because it was a really big thing a couple of days ago. They were talking about this big supply chain attack. Let's go over here. Alright, so the funny thing is that it says that hackers left empty-handed after a massive NPM supply chain attack. So I guess the hackers didn't do a very good job. So the largest supply chain compromise in the history of the NPM ecosystem is impacted roughly 10% of all cloud environments, but the attacker made little profit. The attack occurred earlier this week with maintainer Josh Junon fell for a password reset phishing lure and compromised multiple highly popular NPM packages, among them Chalk and degub.js that have cumulatively have more than 2.6 billion weekly downloads. So let's see. Gameboy says this is not a new attack. It's not a new attack? This is reported on September 10th. So I'm just grabbing stuff from the last 2 weeks. Because we're going to be, I'm hoping to do this news segment once every 2 weeks. After getting access to Junon's account, the attackers pushed malicious updates with a malicious module that stole cryptocurrency by redirecting transactions to the threat actor. Thank you very much. Nemax is raiding with a party of 3. Thank you very much, Nemax. Welcome, Raiders. My name is the Shy Hat, and here's some Hack the Planet.
Hack the planet! Hack the planet! Shut up again!
Welcome in, everybody. Okay, so we're just doing some cybersecurity news. We're talking about the news stories, and if you have any comments about any of the stuff we're talking about, leave it in the chat, and we will have a discussion. It'll be great. Okay, so let's see. So yeah, so the threat actor got access to this NPM maintainer, their password for GitHub, or I'm not too sure if they're using GitHub or something else. But they're doing a supply chain attack. There are a bunch of other software that rely on these NPM packages, and if you push malicious code to the NPM packages, then you can potentially affect all the other software that rely on these packages. Okay, so the open source software community quickly discovered the attack, and all the malicious packages were removed within 2 hours. According to the researchers at cloud security company Wiz, one or more of the compromised packages, which are fundamental building blocks for nearly every JavaScript and Node module, Node project, were used in 99% of cloud environments. So that's some pretty big, very big affected surface. So during the 2-hour window where they were available for download, the compromised packages were pulled by roughly 10% of cloud environments. During the short 2-hour time frame in which the malicious versions were available on NPM, the malicious code successfully reached 1 in 10 cloud environments. Okay, this serves to demonstrate how fast malicious code can propagate in supply chain attacks like this one. So luckily, the malicious code was only online for 2 hours, so it could have been much, much worse. So attackers made less than $1,000. Although the attack caused notable disruption, requiring companies a significant number of hours for cleanups, rebuilding and auditing, the security implications are negligible, just like the threat actor's profit. So that's kind of a dig. So according to the analysis by Security Alliance, the injected code targeted browser environments, hooking Ethereum and Solana signing requests, swapping cryptocurrency wallet addresses with attacker-controlled ones. So they're doing some crypto jacking. So the type of payload is what saved companies that pulled the compromised devices from a much more serious security incident, as the threat actor could have used their access to plant reverse shells, move laterally on the network, or plant destructive malware. So despite the massive scale of the attack and the numerous victims, the attackers were only able to divert 5 cents worth of Ethereum and $20 worth of virtually unknown meme coin. So that's pretty sad. Okay, so Socket researchers published yesterday alerting the same phishing campaigns also impacted DuckDB's maintainer account. According to them, the profits traced to the attackers' wallets are roughly $429 in Ethereum, $46 in Solana, and smaller accounts in Bitcoin, Tron, BCT, BCH, and LTC totaling $600. So, I mean, I hope it was worth it. Also noted the attacker's wallet addresses that hold any significant amounts have been flagged, limited their ability to convert, or use the little money that they made. Alright, so Game Boy gave us another story to talk about, and let's talk about that one. So Game Boy talked about, what is this? CVE 2024 7344. So what is this? So this was, they talked about this in January of 2025. So the story of a signed UEFI. What is this? Accept and close. They brought me to the bottom of the page. Okay, let's just skim over this. Researchers discovered a vulnerability that allows bypass of UEFI secure boot, affecting the majority of UEFI-based systems. Vulnerability, which is the CVE, was found in a UEFI application signed by Microsoft Corporation third-party UEFI certificate. Okay, so the vulnerability leads to the execution of untrusted code during system boot, enabling potential attackers to easily deploy malicious UEFI bootkits such as Bootkitty or Black Lotus. So, Black Shell, hello, nice to see you here. Welcome to the stream. Okay, so the affected UEFI application is part of several runtime system recovery software suites developed by Hoyar Technologies Inc., Greenware Technologies, Radix Technologies, Sandfong, Weisei, Computer Education Systems, and Signal Computer. So following is a list of the vulnerable products over here. Okay, so one more time, what is this thing again? So how exactly does this attack work? So Game Boy, if you know exactly how the attack works, let us know in the chat. Because I know that this is this attack affects UEFI secure boot, but I'm not too sure how it's introduced. So what is the attack? You know what? I think let's try asking the AI to summarize it for us. Okay. UEFI is snake oil anyways. That's a bold statement. Okay, so how does the attack in this CVE work? So you'd have to get physical access to the device in order to install this, right? Okay, it's a vulnerability impacting UEFI-based systems. Specific UEFI application called Reloader. Okay. Reloader.efi contains a hidden unsigned binary. The UEFI application itself is signed with the Microsoft certificate. So use of this vulnerability allows execution of untrusted code during system boot. So if it's... Okay, so let's see. Hybrid Petya ransomware. Hybrid Petya ransomware. Okay, Let's search for that. Okay, let's take a look at one of these articles. UEFI compatible hybrid Petya ransomware. So this is recent. So the vulnerability they use was discovered last year, but the attack that is happening is from this year. Okay. So new ransomware samples, which is called hybrid Petya, resembling the infamous Petya not Petya malware. They were uploaded to VirusTotal in February 2025. It can compromise UEFI-based systems by installing a malicious EFI application into the EFI system partition. So I didn't know that malware could affect the EFI. Well, apparently it can. Okay, so one of the analyzed hybrid Petya variants is going to use this CVE to bypass UEFI secure boot on outdated systems, leveraging a specifically crafted cloak.dat file. Okay. So the algorithm used to generate the victim's personal installation key. Telemetry shows that no active use of hybrid Petya in the wild yet. Thus, hybrid Petya may be just a proof of a concept developed by a security researcher or an unknown threat actor. Furthermore, the malware does not exhibit the aggressive network propagation seen in the original NotPetya. So I guess I wonder how they originally got hold of the sample if it's not being used in the wild. But anyways, yeah. So that's Hacker News for today, which is September. What is it? September 12th. September 12th, 2025. Nimax says, better use core boot or LibreBoot so your device is not backdoored per default. What is core boot and LibreBoot? Let's look that up real fast. Core boot, LibreBoot? Is that for, I mean that, oh, this is open source BIOS and UEFI boot firmware, okay. Black Shell says, is this the vulnerability that Microsoft had in 2025? Well, I mean, the CVE that is being used is from 2024, which is this one right here. You can look it up yourself if you like. Okay, so yeah, we talked about the Burger King hack, and then people talking about the predictions for AI taking over ransomware attacks in next year, I guess. We talked about AI created annoying CAPTCHAs, which gave me a big headache, and we talked about the NPM supply chain attack. I wonder how many projects use NPM. So I'm not super familiar with NPM, but let's ask a couple questions. So what is NPM in terms of software development? Ask questions, get answers. So Node Package Management Manager, and is a fundamental tool in the JavaScript Node.js ecosystem. So it's a command line tool and online repository that helps developers manage JavaScript packages and dependencies. It comes bundled with Node.js when you install it. All JS projects use NPM. All JS projects use NPM. So that's a pretty big attack. And they managed to pull it off for 2 hours before it got caught. And then they yanked the plug on it. So that is pretty big. I think if you're on YouTube, I think John Hammond also talked about this. Okay, let's look it up. NPM hack John Hammond. I saw a video of his talking about this. Yeah, wait. Huh, didn't he publish something? I thought he did a video. Yeah, this one right here, 4 days ago. Largest supply chain attack in history, something something. Blackshell says, oh, thank you very much for subscribing, Archondrius, thank you. Blackshell says, no way, I started learning Node.js this week. I want to go back, learn more about the backend. Highbrow, hello, nice to see you here. I will tell myself when I see that NPM. So yeah, there's the YouTube video from John Hammond if you want to check that out. And yeah, so I mean, it's a really big story because of the how everything uses NPM apparently. But let's go ahead and what can we do for the next 20 minutes? Because we got about 20 minutes left in this segment. I guess we could go looking around for some news as well. So, what are some good? If anybody has any good websites for hacker news, I guess there's a hacker news site as well. So hacker news. Hunt for blind SQLI. Highbrow, were you talking about blind SQLI last time? I remember you talking something about it. Okay, UTF-8 is. I mean, this looks a lot like Reddit. I'm guessing that Defus, hello, nice to see you here. And you're recommending a blog article. Okay, let me take a look at this. So, Highbrow, I'm pretty sure I sent you a link for a Try Hack Me room talking about blind SQL injection. Bad Sector Labs. Okay. So this is another site you could use for hacker news stuff, I'm assuming. This looks like it shares the same kind of architecture that Hacker News uses. Thehackernews.com. Okay, so this is Bad Sector Labs, last week in security. Okay, so let's see. Last week in security, they publish it every week. Okay, let's take a look at what we have this week. Highbrow says, I want to see you do it live. I mean, what was it you're looking for? Blind SQLI? Blind SQLI is very tedious to do manually. I would rather not do blind SQLI manually. I mean, you probably want to, look at another creator if you want to see somebody do blind SQLI injections live. If that makes me not a real hacker, then I'm not a real hacker. Okay, so let's see. Spectre Bash, techniques and write-ups. The renaissance of NTLM relay attacks, everything you need to know. NTLM relay attacks continue to be effective, and even disabling NTLM doesn't save you from relaying, as Kerberos could be relayed in some instances. Who do you recommend? Well, I mean, if you want my recommendation for people who do a lot of web app hacking stuff, I mean, let's see. Probably somebody like Nahamsec. Nahamsec is a really big channel who covers a lot of bug bounty stuff. So this is that channel. And I think Rana Khalil is another big creator. Oh, Inside PhD. Yeah, bug bounty. Let's see. So these are some of the larger content creators for web and bug bounty stuff. XSSRat. Highbrow says, I need someone that will do it with a real target. If you're talking about real target as in not an education environment, then I don't know if I can help you there. Because you don't ask people to. If it's not an educational environment, then there's a possibility that you're doing illegal stuff. And don't ask people to do illegal stuff. Okay, let's go back and see if we can see some news. So the renaissance of NTLM relay attacks. So these continue to be effective. I mean, NTLM relay attacks, this is the type of stuff that you see when you... Game Boy says, show him how to hack the Indian bank. If I knew how to hack the Indian bank, well, I mean, I wouldn't hack the Indian bank. Because that's not that's bad guy stuff. Or is it on a bug bounty program? Listen, if you're doing a bug bounty program and you hack like and you discover an SQL injection vulnerability, you do not want to do that live, because then you're showing everybody who's watching the live stream how to hack like some website out there. Black Shelf says, we're white hats. Well, we try not to do criminal stuff on the channel, because if you do criminal stuff on the channel, then you can have your channel banned. And I don't want that. Okay, so let's see. Meet C2, a framework abusing Google Calendar APIs. Okay, so I heard about this one from Smashing Security as well. Game Boy says gray. I guess so. I guess if you're not making money from the hacking, you could call it gray hat stuff, unless you're actually attacking with a malicious intent, in which case then you are doing black hat stuff. But you know what? One other place that you could go to learn about blind SQL injections is you could try hack me. I'm pretty sure that the DVWA machine. This one over here. Am I not logged in? Just a second, everybody. I'm going to have to log into my account. And while we're at it, we can put on some new music. How about some of this? Okay, so DVWA, OWASP Juice Shop. Well, I mean, the thing about the OWASP Juice Shop is that it's kind of like a challenge room. The OWASP Juice Shop is more like a challenge room. The DVWA is more like a learning environment. Gameboy says simple password. Ciro says I still have no hat because I'm just watching content. I should really start learning. I mean, yeah, you can start learning at any time. You can tell from many questions. You can tell from many questions that there are no ethical hackers here in the chat. I would hope to assume that most of the people here are not don't want to do criminal things with their hacking. Because if I see people, talking about how they want to be criminals and brag about, committing crimes, I'm going to have to ban those users. Because we're only here to promote good things. Okay, so in just a second, we'll be able to... Well, I guess we need to start up our attack box if we want to interact with the thing. Checkpoint.com, okay, also a good place to check weekly, but it's more technical write-ups for new hacks than security news. Hacker ethics, yeah. Thank you very much, Nemax. But yeah, remember everybody, use your hacking for good and not evil, okay? Sarah says, I didn't realize he had hat in his name before. Yeah. I guess a lot of people don't notice these things. It's okay. But yeah, I just want to check with the DVWA to make sure that they have blind SQL injection. Most of the time, when you do blind SQL injection, you're gonna leave it to some sort of tool. So stuff like SQL map or some sort of Python script that you write up, because doing it manually makes you want to. It's not very fun. It's not very fun at all. So let's see. Anonymous Cells says they still abuse it if they can hack a little, and that's a shame. I mean, give people a little bit of power, and you'll see what their actual personality is like. Hopefully, everybody here is a good person and not a potential criminal. All right, so in just a second, we're going to be checking the DVWA app, and I'm pretty sure that there is some blind SQL stuff. Okay, we got it here. Let's start up the browser. Diva says, I did my criminal tech stuff when I was young enough to not get in jail. Well, don't tell me about how you committed crimes. Sarah says, actually being an illegal hacker seems like a childish fantasy because it looked much cooler when I was younger. I mean, the reality is that a lot of people do like illegal hacking when they're young, because the way the laws work in a lot of countries, once you become an adult, everything that you did when you were a kid, it all gets erased. Not that I'm advocating anybody to do anything illegal when they're young or anything. Okay, so this is the DVWA app, and they've got blind SQL injection here as well. So what I would recommend, if you want to learn about blind SQL injection, you can use the DVWA app, and then you can start, well, I mean, if you don't know how to do it, you can probably look up a guide somewhere that talks about this, and then you can follow the guide. It'll talk about how to do the blind SQL injection. So if I were to just search for this, it should be very easy to find something like this. Thank you very much for subscribing, Anders Frederick. Thank you very much for subscribing on YouTube. So DVWA, blind SQL injection walkthrough. Okay, Gameboy says, without bad, no good. Without bad, you not move. Be good and move. Well, okay, so we've got a few different write-ups here talking about the blind injection in the DVWA app. So what I would do, you don't necessarily need to see it done on a live system. You can use these learning environments to learn about basically any of the attacks and the vulnerabilities. So if you do a crime, you're gonna sit for a time. It's everything comes through a lot easier if it rhymes, of course. Okay, so let's see. We have another 10 minutes or so before we need to start the next thing. But yeah, if anybody else has any questions about where to find other training materials.
Hey! Who are you people? What do you want from me?
We want the numbers, Mason. We want the numbers. That's all we've ever wanted.
The numbers. How do you use the numbers? All right, so I think somebody else talked about AI prompt hacking. I'm not too sure if anybody has any clues as to what kind of resources you can use for AI hacking educational materials. Let us know. I mean, there's always the Gandalf AI game, so Gandalf.lacera.ai. So which is this one right here? Oh. Let's go back to here. So this is a game where you need to use your prompt injections to fool an AI into giving you passwords. Aside from this, I'm not really too sure what educational resources exist for this stuff. Oh, you know what there is? There's also Portswigger. So somebody asked me for this in one of my YouTube videos recently. And let's see. So in the Academy for the Portswigger website, they've got some stuff for AI attacks. Where is it? Let's see. View all labs, view all learning materials. Is that prompt engineering? Yeah, that is prompt engineering. LLM. No? Where is it? I could have sworn. Let's see. All labs. Or latest topics. Web LLM attacks. Here we go. Okay, Hybra also asks, what about NoSQL? NoSQL, yeah. So if you want to learn about LLM attacks, this is where you would go. There's a whole section on NoSQL injection on Portswigger as well, I'm pretty sure. I mean, it should be here. Let me look it up real quick. So all topics. NoSQL. Yeah, NoSQL injection. We got some topics, we got some labs. So Highbrow, if you want to take a look at this. I'm pretty sure there's there is this kind of topic on for Try Hack Me as well. Just a second. Why? Sometimes I really don't like the way they organize the website over at tryhackme.com. So it says, how much time were you doing cybersecurity? I mean, I've been learning about cybersecurity for the last 5 years or so, but I still don't think that I'm super proficient. I'm still a learner myself. Okay, so why? Wait, am I logged in? I am logged in. Okay, let's search for something. Search NoSQL. Yeah, NoSQL injection. Is this a free room or not? I'm not too sure. Join the room. Can I join the room? Okay, this one's free. So, yeah. So, Highbrow, if you want to. THM has had that issue for years. THM, the design of the website. Sometimes some of the design for the website is not that great. Okay, so let's see. I guess we can talk a little bit about what we're going to be learning later on today. So let's see. We're also going to be doing MicroCorruption.com after the basic Linux class we're going to be doing. I like the UI of TryHackMe. I like the UI of TryHackMe. Some people disagree. That's okay. Yombinator, Bearer Bonds. Okay, so this is a game that teaches you how to use assembly, or well, I mean one of the assembly languages. We'll be talking about it in about an hour or so, but HTB site is much more confusing in my opinion. Yeah, it's because there's a lot of stuff that you have to interact with on the site. And it's also designed by hackers. So it's designed by hackers and not web designers. Meant Hack the Box. Okay, you like the design of Hack the Box. Right. People get Hack the Box and TryHackMe confused all the time, which is something that the people that like either one of those sites doesn't really like either. Anyways, let's get set up for the next topic. So the next topic we're going to be doing, not Hacker News, not this. We're going to be doing HackerFrogs AfterSchool. We're going to be solving more challenges inside of Linux to learn how to use Linux. And to anybody who doesn't know, there's actually a very good website that you can use if you don't have access to a Linux machine. There's this web-based Linux over here. It's called JS Linux, and if you use the website, you can get access to a web-based version of Linux. You can play around with it. You get root access, which means you can basically do whatever you want on it. It's a very good alternative for people who don't have access to the hardware. And aside from that, what else do we need to set up? So let's see. We're going to be doing HackerFrogs AfterSchool Linux Session 3. So we're going to be referencing a lot of different challenges today, and the challenges over at picoctf.org. What Linux topics are you teaching today? So we're going to cover a bunch of miscellaneous topics for Linux today, but the most important thing we're going to be doing is we're going to be learning about how to do piping, and command piping is a very important aspect of working inside of Linux. So we're going to be covering these challenges over here. If you don't have an account over at picoctf, we're going to be using a lot of picoctf to work through challenges and learn more about Linux. Defa says, how do you have the hardware to run a browser but not to run Linux? Well, not everybody is watching from a laptop or a desktop computer. Some people are accessing this live stream from a tablet or a phone. But I guess if you're using a tablet or a phone, it's going to be very difficult to type in commands. But yeah, some people just have Windows, and they don't really have the technical savvy to run Linux. So there are ways to run Linux without having to, Frackery says, Bluetooth keyboard for the win. Yup. Sarah says, I did some Linux courses like 3 years ago, but in fact, I'm usually only using basic commands. I mean, most of the time, you don't need to know a lot of advanced commands to work inside of the Linux terminal. And a lot of the time, if there's something you want to do inside of Linux, you can always Google it. So let's see. How to create a new user in Linux. This isn't something I do. This isn't something that most people do, but you can, you can just look it up. So sudo user add -m username. So if I want to make a user, I can just go over to the Linux terminal here and just use the information that you Google up. So let's see. We'll make a user. We'll call him HackerFrogs. So it'll ask me to do a bunch of stuff, and then at the end, we'll be done. I like the motto, read the manual. It helped me stop relying on IA. IA? So the problem with using the manual is that sometimes it usually takes a lot longer to look stuff up in the manual than it does to search it up on the internet. But let's see. So if we created the HackerFrogs user, it should be in here. Yeah. So there's a HackerFrogs user, and we don't actually know what the HackerFrog user's password is. We could probably look it up. So HackerFrogs, looks like there is no password. I'm not too sure what it means. Okay, so let's see if we can become the HackerFrogs user. Oh, it's thinking. Okay, now we've become the user. Who am I? We are HackerFrogs. Awesome. Okay, so let me switch up topics. We're going to be starting the new topic for Linux stuff. Okay, so let me start the class. I'll put an hour on the clock. We should be done in under an hour or so. Let me close up some of these windows that we're not using. Just a second. HackerFrogs AfterSchool, Linux, Session 3. Okay, so let us start. Alright everybody, we're doing HackerFrogs AfterSchool. Linux Basics with PicoCTF Part 3. So this is the third part in our 5-part series on Linux Basics. Let's start. So what did we learn in the previous workshop? Hey there, HackerFrogs. This is the third intro to Linux OS Operations workshop. In the previous workshop, we learned about the following Linux commands. So we learned about the find command. So the find command is used to search for files on the system. It can be used with many different arguments and flags to refine the search parameters. So if we've got our Linux system over here, I could look for all the text files by doing this command. So find /name star.txt, and it'll tell us where all of the text files on the system are. So it's a very, very useful command when you're searching around a system for specific types of files. Anyways, this is going to run for a while. I'm just going to leave. Okay, so the find command, we also use the grep command. So the grep command is another very useful command we use inside of Linux. We use it to search for specific strings. Searches within the contents of files for specified strings. It is very commonly used to pick out specific words or phrases. So let's demonstrate over here. So if we run grep on etc password, and we look for a specific pattern. Actually, wait. We'll look for the word shy in etc password, and it'll get you just the line in the file that has the specified search parameter. In this case, it's the word shy, and this is a file with all of the users on the system, so it will get you just that line. So this is very useful when you want to search for stuff inside of files. So if we wanted to look for the root account in the password file, we would look for root, and then it gets us just the line with the word root. Okay, so that is the grep command. We've got the make directory command. So this is very useful when you want to keep organized in your file system. So it's mkdir and then the directory name. So in here we can make a directory named the shy hat just for fun, and then we see that we've got the shy hat as a directory in here. We can enter that directory. Of course, there's nothing in here. That's fine. So we make directories and then we put files inside of them, to keep nice and tidy. Okay, and then the rm command. The rm command is used to delete files. It's a very, very commonly used command, especially when you want to, manage your files and make sure that you don't keep files around that you're not using anymore. So for example here, we've got a directory, the shy hat, that we don't want to keep around. So we do rm-r on the shy hat, and that'll delete the file, or the directory in this case. So let's say we've got a temp.txt file. We can delete it by doing rm temp.txt, and then it disappears. Nice and easy. So the one thing you need to keep aware of is that inside of Linux, there's usually, especially inside of the Linux command line, there's no recycle bin. If you delete something, it's gone. So you need to be careful, and you need to be sure that you want to delete something when you delete something, because you're not getting that back. Okay, so the rm command, let's continue where we left off. So we're going to be solving a bunch of challenges on the PicoCTF platform to learn about Linux. And before we do that, let's log into PicoCTF. So you'll want to navigate to this webpage here. And after you're logged in, you want to click on the practice button over here. So click on the practice button at the top of the page. And after that, you want to click on the web shell button, because we're going to be using the web shell to practice using Linux. After you click on practice, you should see the web shell button on the left-hand side of the screen. It's labeled web shell. Click on it. And then after it finishes loading up, we want to put this in full screen because, well, I mean, we don't want to have the web shell nice small, because we want it big so that it's easier to see. So we're going to click on this button beside the help button in the web shell, and it's a picture of a square with an arrow pointing out. It's labeled Pop Out Web Shell Terminal. Click on that, and then you're going to see the web shell terminal expand into full screen in another browser tab. So this is what you want. You can also adjust the size of the web shell terminal. So just click on this button in your browser in the corner. You can make it smaller by clicking on the zoom in and zoom out. Just make sure that it's at a size that's comfortable for you. And then after you're done, you can clear the screen with the clear command. We should aim to keep the our directory here as clean as possible. You've got this read-only file over here, readme.txt. That can stay, but everything else, you want this to be empty when you finish your challenges. Okay, so let's go ahead and do the first challenge. So the first challenge is this one over here. It's called What's a Netcat? So I'll get the link for everybody. Okay, so let's access the challenge. Alright, so this challenge is called What's a Netcat? It's an easy challenge, general skills, PicoCTF 2019. The description says, using Netcat is going to be pretty important. Can you connect to this server over here on port this number to get the flag? So what we're talking about is we're using a specific command, and the command is called netcat. Let's talk about it for a second. Okay, the netcat command. So netcat is a program in Linux. It's not only for Linux, but it's very commonly used on Linux systems. It's a very versatile computer networking program, and one common use of netcat with PicoCTF challenges is to connect to non-standard services on remote servers. So netcat is a program that'll let you connect to another computer, but it's different from the SSH program that we use to log into remote servers. And this is how you use it. So the syntax for using netcat to connect to a remote server on a specific port is as follows. So it's NC for netcat, and then the IP address or domain, and then the port number. So for example, in this challenge, it's NC jupiter.challenges.picoctf.org. This is the name of the server, and the port that we're connecting to is this one right over here, so 41120. So I'm pretty sure we can all use the same command here. And I've left the command in chat. So if we go over to our web shell, you're going to see that the web shell disconnects you if you don't send commands to it within a certain time. You can hit the enter key to reconnect. Okay, and then you can paste in the command we're supposed to use here. So remember, it's NC for netcat, and then the name of the server, jupiter.challenges.picoctf.org, and then the port number, 41120. So when we give that command, it'll say here, as a response from the server, you're on your way to becoming the netcat master, and you get a flag. So remember, we need to submit these flags to the challenges, and that'll let us complete the challenges. So you just need to highlight the flag, copy it, and then go to the challenge description. In the challenge description, there's a field for submitting the PicoCTF flag. Paste it in, click on Submit Flag, and then you're done. Sorry, that flag is incorrect. Oh. Okay, so they've got some protection. So we have to use a different port. So you might not have the same port as I have for the port. You need to use the port that's in the challenge. So for me, it's 25103, but for you, it might be something different. So let me copy this in the web shell. I'm going to escape from this program. And remember, if your terminal seems stuck, you type stuff in and nothing happens, you can escape from this by using the Control-C keyboard shortcut. So hit the Control key on your keyboard, hit the C key on your keyboard at the same time, and you're going to see this symbol, and then you're going to be able to use your terminal again. So you can access the history in your terminal. I'm just going to use this number, which is my number, I guess, and I'm going to copy the flag. So the problem with with the flag is that this number here, it's going to be different depending on which port you use. And I guess this is the port that I'm supposed to use, which gives me this different flag. Okay, and let me go ahead and submit that flag. So I'll delete the old flag, I'll paste in the new flag, click on submit, and then I have finished the challenge. Okay, everybody, if you managed to finish the challenge along with us, please type in the chat, "I am the Netcat Master," smiley face. Okay, let's move on. We're going to move on to the Pico CTF plumbing challenge. So let's learn about command piping with the Pico CTF plumbing challenge, and we've got another link. So let me grab the link for everybody. Meow, I am the Netcat. Well, okay, if you say so. All right, thank you very much for following, Lucius Marquis. Thank you. Thank you very much. Okay, let's move on to the next challenge. So the next challenge is plumbing. Okay, so it says here, so this is a plumbing challenge. It's a medium. I don't know why they say this is a medium level challenge. I guess it's not exactly super easy. It says sometimes you need to handle process data outside of a file. Can you find a way to keep the output from this program and search for the flag? So they've got, it says connect to here. So if we've got a server and we've got a port number, if we have a server and we've got a port number, how do we connect to this? What program should we use? If you have the answer, let us know in chat. The answer is that we can use the same program we used for the previous challenge. So in the previous challenge, we used the netcat command, and so Game Boy says SSH. I mean, SSH would work if we had a username, but we don't have a username or password, so we should probably use netcat instead. So this is, let's see. Before we do the challenge, let's talk about what command piping is. NetDog, of course NetDog. Okay, so we're talking about command piping, and this is going to be a very important thing that you learn when you're working inside the terminal in Linux. It's something you do pretty commonly. So in Linux, command piping is the process of passing the output of one command into the input of a second command. So in this case, we give the first command, and whatever output we get from that command is going to become the input for the second command. So this is a very useful feature because it allows commands to be chained together to achieve a lot of flexible output. And let's demonstrate what command piping can do for us. So, for example, if we echo out something, so the HackerFrogs, we can pipe the echo command that just echoes out the HackerFrogs, and we can transform it using base64 to encode it like this. So we can also, if we just echo out the HackerFrogs, but we want to transform it, just doing this isn't going to work. We need to combine it with the second command. So the output for the echo command becomes the input for the base64 command. So Frackery says IO IO. Every stream has an input, an output, and an error. So this is something that we need to understand. There's output for the command, there's input for a command, and there's error messages for the commands. So for example, if we echo testing, this is the output of the command. So when we use piping, we use the output of one command as the input for another command. Let's talk more about this. So we're going to be doing some command piping over here. We're going to be accessing the port on picoctf using netcat, and then we're going to look for the flag using the pipe and then the second command over here. Let me demonstrate. So we got these numbers. You're going to have to copy these numbers from the description because the port number is going to be different for every user. Okay, so in the web shell, I'm going to paste in that that server and the port number, and I'm just going to put netcat in front of it. So if we just run this command netcat to connect to the server, it's going to give you a bunch of output over here. So it would be a big pain in the butt sifting through this output to look for the flag. So what we're going to do is we're going to run netcat and we're going to pipe it. Frackery says some bash one-liners are super dense and extremely useful. So what Frackery means here is that thank you very much Christopher Smith for subscribing on YouTube. You're now HackerFrog. And thank you very much for subscribing the real Mo AI. Thank you. Okay, so what else do we have here? It looks like double subscribes. Thank you. Thank you very much. So what Frackery means by bash one-liners are basically bash commands that are all in a single, that are all, you know, done as a single command, but they're usually chained together by pipes. And the pipe character looks like this. It looks like a straight up and down line. It's usually the shifted version of the backslash on American keyboards. So what we can do is we can grep for something. We can grep for the word flag. So this is going to highlight all the word flag inside of the output here. And what we want to do is we want to get, they're usually longer the more specific they are. Thanks for the shout out. No problem, Christopher Smith. Thank you. GX000 says, I can't smoke that pipe. It's not a pipe you can smoke, GX000. Nice to see you here. Okay, so we're just going to pipe this out, and we're going to look for the picoctf flag. We know that all the picoctf flags begin with the word pico, so we can grep for that. And we get exactly the flag here, instead of getting all this junk output. They all begin with picoctf, that's true. Just pipe the smoke to dev null. Isn't that cheating? Yeah, I mean, hacking is cheating. Hacking and cheating are very, very similar. Alright, so we got the flag, so we can submit this. If you managed to get the flag by grepping and piping, please let us know in the chat by typing out the words grep, grepping, and piping. Smiley face. Okay, let's submit this flag and complete the challenge. So copy that, go back to the challenge, paste it in, submit the flag, and we're done. Grepping and piping. Thank you very much. Is it Revan? I'm not too sure how to pronounce your username. Or it's just XR? Is it XR? I'm not too sure. All right, let's move on to the next challenge. So we've got another challenge to do. We got a bunch of challenges that we're doing today. The next one is called bases. XR keeps it easy. Thank you, thank you. Okay, so this is the bases challenge. And the bases challenge, this is an easy challenge, General Skills picoctf 2019. And what does this mean? I think it has something to do with bases. So it has something to do with bases, yeah. If you don't know what this could potentially be, let us know in the chat. If you don't know what it is, let us know. I mean, there's no shame in admitting that you don't understand what's going on in the challenge, because we're going to explain it. We're going to explain what's going on. So we're talking about encoding. Yeah. This is base 64. This is the base 64 encoding system, and let's talk a little bit more about this. Okay, bases challenge. So the base 64 command. So the encoding system that we're using is called base 64, and base 64 is a command inside of Linux. Frackery says, I've never seen such a small base. That's very judgmental, isn't it? Anyways, the base 64 command encodes and decodes data according to the base 64. Well, this is a system. It's not necessarily a codec. Anyways, it is often used to convert data for transmission across computer networks. And the reason we need to do this, we need to transform the information. There's a bunch of different reasons, but I'll talk about it a little bit later if we have some time. So the characters used in base 64 encoding are shown here. So it's called base 64 because a full set of the encoding is 64 characters long. So from the numbers 0 to the number 63, it's basically all of the uppercase letters, all of the lowercase letters, all the numbers, and the plus symbol and the slash symbol. A calm like a CM. Well, I mean, you gotta be honest to yourself, Frackery. All right, so let's go ahead and talk a little bit more about this. So note that all base 64 encoded strings must consist of a number of characters that is divisible by 4. So let me do a little demonstration on the Linux terminal here. So if we echo out, this is a sentence that has not been encoded into base 64. And then we pipe that into base 64, the command. This is what the sentence looks like after it's been encoded into base 64. So we can do the opposite here. We can also decode this. So if we grab this, we echo this line out, and then we pipe it into base 64-D for decode. Then we get the original sentence back. So we take the encoded string, then we decode it from base 64, and we get this sentence over here. Alright, so everybody, we're going to take a little break because we've got ads running on Twitch. We'll run them on YouTube, and we'll be back in about 60 seconds. So in 60 seconds, we'll be coming back to the lesson, but in the meantime, watch these birds. I'm going to take a little water break. See you in 60 seconds. Okay, and I think there's one more bird that shows up. Where are we? Here, right. Okay, so this is a woodpecker. It's one of my favorite birds. But we're not necessarily here for the birds. Let's get back to the hacking. But yeah, in all of these demonstrations here, we're basically piping one instruction into another instruction. So this is input, this is output here. That becomes input for the base 64 command. through the pipe. And here we encode a message, and we decode the message by doing the same thing. We echo out the message, we pipe it, and then we run the decode function over here. Okay, let's go ahead and solve the challenge. So another thing that we need to know about base64 is that in the cases where the encoded string is not going to be divisible by 4, the encoding process will pad out the string with a number of equal symbols until the string is divisible by 4. So if we use base64 to encode the word password, the encoding actually doesn't produce a number of characters that is divisible by 4, so then we need to add an extra character, an extra equal character at the end to pad this out. This is actually a very common way you can identify base64 encoded strings. You're going to see a number of equal signs at the end with a bunch of numbers and letters at the start. If we echo out something really short, like test, and we base64 encode it, we're going to see an equal sign at the end over here. If we make it even shorter, so let's say we encode the word taught, then we're going to see more equal signs. So 2 equal signs, because it's not quite long enough to be encoded into a number that's divisible by 4. And how about 2? If we encode 2, then it becomes divisible by 4 again. Okay. Anyways, let's finish the lesson, or finish this challenge rather. So we're going to use the echo command to echo out the word that's provided by the challenge. So echo this, and then pipe it. The pipe is over here. We're going to run the base64 command to decode. So we're going to decode it with the -D switch. So it is this string right here. We use the echo command to echo it out. We pipe it into base64-D for decode. And then this is learn the ropes. So learn the ropes isn't the entire flag. So if anybody knows what's missing from the flag, let us know in the chat, because there is something missing. So we got this flag, or this part of the flag. The problem is, if we just submit this as the flag, it's going to say the flag is incorrect. So Pico, yeah, Game Boy has it correct. So this doesn't have the PicoCTF wrapper. So the PicoCTF wrapper is this. So it's PicoCTF, and then some squiggly brackets, and then the contents of the flag go between the squiggly brackets. Okay, so we're just going to get rid of what we just typed over here. We're going to paste in this, and this is the complete flag. So most CTF games have a flag wrapper kind of like this. So it's going to be some squiggly brackets and something at the beginning. It's not necessarily going to be PicoCTF every time, but it's going to be something, and it's going to be consistent for the platform. So we're just going to copy that. I'm going to go over to the challenge, paste in the full flag, and click on Submit Flag, and then we're done.
Hack the planet! Hack the planet! Shut up and get it!
Thank you very much, Agent 57. Thank you very much for Hack the Planet. Let's go on and do the next challenge. All right. The echo command. Yeah, so we've been using the echo command a bunch in this lesson, but let's talk about what exactly it does. So the echo command is used to create output equal to whatever is supplied to it. It can be used to supply input to another command through command piping. So most of the time when you use echo, you don't use it by itself. Agent 57 says, sorry, you know I like to lurk. No worries. I thought there was an echo in here. Ha ha ha. True. True, true, true. Just a second. I gotta start up the music again. So most of the time when you use the echo command, you're using it with another command through command piping. So for example, this is an example of the echo command that we use to supply input to the base64 command. So echo and then a string and then pipe and then base64 to encode this thing. So the echo command can also be used to create files containing the echo content by combining it with output redirection. So for example, echo test and then greater than sign output.txt. So the above command is going to create a file called output.txt with the text content test. Agent 57 says, command bonging I do more than piping. Well, I mean, there is that. Anyways, so for example, if you echo test into output.txt, let me demonstrate this. This is actually something we do pretty commonly in Linux. So if we echo test to output.txt, we're going to create a file called output.txt with the file contents test. And we do that by redirecting all of the output, or redirecting all the output to this output.txt file. So if we do that, we're going to see that we created an output.txt file here. If we read the file with the cat command, it's got the word test in there. Agent 50 says, anyways, let's get back to the hacks. Isn't that Gar7? Gar7 has that, that's one of his, what are they called? Transitions. Anyways, let's get back to the hacks. Okay, so we just talked about output redirection. And output redirection is a feature in Linux that can be used to direct the output of commands and write that output to a file. So the previous echo command was an example of this. So for example, the above command is going to take the output of the find command and redirect it into a file called jpeg-file-list.txt. So this is a useful technique that can be used to save the output of commands for later use. So this command right here, I'll just provide it to everybody in chat. So if we run this command, the command is find name star.jpg. So it's going to look for all the JPEG files. We can give this over here, the greater than sign, to redirect the output of the command into a file. And the file is going to be called jpeg-file-list.txt. So when we run this command, we've got a file called jpeg-file-list.txt. If we read it, this is the list of all the JPEGs. This is the output from the find command. So output redirection is very, very useful when you're trying to when you want to save the output from a command into a file. Okay, so let's do the PicoCTF repetitions challenge. Let's practice the concepts we've been learning this in this lesson in this challenge right here. So repetitions, is this the last one? Huh. We might have to find some extra challenges after this. All right, so this is the link. As usual, if there's any questions that you have about the challenges that we did today, let us know, and we'll try to answer your questions as best we can. Okay, so the repetitions challenge right here, it's an easy challenge, and it's also got base64 associated with it. Can you make sense of this file? Download the file here. So we got a link for the first time today. What we can do is we can highlight the link, right-click, and we can select copy link. So what we're going to do is we're going to download the link to our web shell. So back at the web shell, we can hit enter to reconnect to the web shell. Okay, so there's nothing here. We're going to use the wget command to download the file. So type in wget, hit space, then right-click, select paste, and that should paste in the file address for the file that we need to download. So just hit enter to download the file. Yeah, we could use curl or we could use wget. So wget is much more, it's an easier command to use because it's just wget and then the address. So after you finish, you should have the encoded flag in your current directory. So if you downloaded the file, let us know by typing in flag, file is here, smiley face. If you're having trouble, let us know in the chat. We'll try to help you out. So we're assuming that everybody's working inside of the web shell. Give me the link. The link for the file is here. So I think we're not using the same link. So every player is going to get a different flag file. So if you want to submit the flag, you need to download your own file. Okay, so what is this file here? So if we run the file command on the file name, it'll tell you what the contents are. So it says the contents of this file are ASCII text. If you read the file with the cat command, it's going to be a bunch of base64 encoded information. So remember that base64 encoded information is a string of letters and numbers, and occasionally you see special characters. The telltale sign that something is base64 encoded is that they've got equal signs at the end of the string. So what we're going to do is we're going to base64 decode this. So base64, and it looks like, is somebody subscribing? Oh wow, GX00 just subscribed with Prime Gaming. Thank you very much, GX000. Hey, if you don't know about subscribing with Amazon Prime on Twitch, here's a little guide. You can, if you want to, you can subscribe to your favorite Twitch streamer, or you can subscribe to me, one or the other. Okay, everybody. So what are we doing here? We're gonna be base64 decoding this string. So it's gonna be base64-d on enc_flag. So this is the other way of using the base64 command. You use it on a file. GX00 says, you are our favorite Twitch streamer. Well, if that's the case, then thank you very much. Okay, so we gave this command right here. So let me copy, provide it to the people in chat. Okay, so something interesting happens when you base64 decode this. So we decoded the contents here, but it still looks like this is base64 encoded. So what we need to do in this case is we need to decode it again. And we can decode it again very easily by piping this. So we'll give the same command that we did previously. We'll pipe it into base64 decode. So when we do that, it looks like we still have more base64 code. So we decoded it once, we decoded it twice, we still see more encoded stuff. So we're going to pipe, and we're going to base64 decode again. So when we do, each time we do this, you'll notice that the string becomes smaller and smaller. That's because each time you base64 encode something, it becomes longer. So let me demonstrate this over here. So if we echo out, we are HackerFrogs, and then we pipe that out to base64, this is the string here, but we can actually double encode this. If we double encode it, we basically pipe it into base64 again, and it becomes longer. if we pipe it into base64 again, it becomes an even longer string, because each time you encode something, it becomes larger and larger. But we can, yeah, so what we're doing here in this exercise is we're decoding it over and over again. Okay, so we're just going to keep on decoding it. So this is number 1. 1 decode, 2 decode, 3 decode, 4 decodes. This reminds me of a challenge where they base64 encode the flag 64 times. Triple encoding is common, is it? I mean, I guess as far as like, as like hiding your information is concerned, sometimes you will see information that is, after it's decoded, it's still decoded, but it's another layer of decoding. Okay, so we're going to do 5 decodes. 1, 2, 3, 4, 5. This is 5 decodes. Next, we're going to do 6 decodes. Okay, so after 6 decodes, it says base64 nested decode. Download. Okay, so we can just copy the flag here. And we will go back to the challenge. So in the challenge description, paste in the flag, submit the flag, and then you're done. All right, everybody, if you managed to finish that challenge, let us know in the chat by typing in base64 onion, peel it back. Smiley face. All right, I'm just going to have a little sip of water because I do a lot of talking here. Yep, we're hydrating. But I wonder if there are any other challenges we can do. So what we learned today is, well, we'll talk about what we learned today. And then we'll do some extra stuff.
Bud. Wives. Bud. Bud. Wives. Bud. Wives. Bud.
Thank you very much for the Budweiser Frogs redeem in GX000. Thank you. And thank you very much for following Datalore TV. Datalore TV? Let's give you a fun video redeem. How about some Nyan Cat? Okay, so what did we do in the repetitions challenge? And thank you very much for following Surprise 5G. Frackery says, "Wow, that commercial is old." It's I think it's from the early 80s. It's really old, yeah. Okay, so let's talk about what we did in today's lesson. So we learned about the netcat command. So netcat is a versatile computer networking program, and one common use of netcats with Pico CTF challenges is to connect to non-standard services on remote servers. So there are 2 common ways of connecting to a remote server with Linux. There's going to be SSH, which is complete login. You use a username and a password, and you get remote access to the computer. The other method is using netcat, and netcat is just going to connect to a random, well, an arbitrary port on a server. It's not necessarily going to log you in. And thank you very much for subscribing, squirrel.dev. Squirrel, it's not .dev. How do you read that? But thank you very much for the subscription. Okay, and we learned about command piping. So command piping is going to be something you do a lot inside of Linux. It's not super complicated to grasp, but it is something you need to get used to. So command piping is the process of passing the output of one command into the input of a second command via use of the Linux pipe character. So one of the biggest challenges to doing command piping is figuring out where the pipe character is. And let me see if I can get a picture. Let's see. US keyboard layout. I know not everybody is using the US keyboard layout, but I think most of the audience is. And So for example, if you've got, can we make this big? Okay, so if we got the US keyboard layout, you're going to see the pipe character over here. And the pipe character, it's the shifted version of the backslash character if you're using an American keyboard. Okay, so let's go back. We also learned about the base64 command. So the base64 command is going to encode or decode data according to the base64 system. It is often used to convert data for transmission across computer networks. So I can actually take a little bit of time to talk about why we use base64, and it's because when you move bytes across a computer network, certain bytes are going to get in the way of the software that's being used to move the bytes around. And so let me get an example of a JPEG file. Let's get a JPEG file. How about this one? Let's see, copy image link. Let's download this. Okay, so oh man, why is it so long? Let's rename this. So we're going to rename this to picture.png. Okay, so now we've got picture.png. If we read the file, we're going to see there's a bunch of bytes in here. So these are non-readable bytes, and most picture files are composed of non-readable bytes. These are not meant for people to read. These are meant for image viewing programs to read. The problem with these non-readable bytes is that they can sometimes interfere with the server that you're sending it across. So what we want to do is we want to convert these non-readable bytes to a standard character set, and we can do that with base64. So these bytes over here, if we send them across the network without encoding them, they could become corrupted, or they could cause errors for the server software. So what we're going to do is we're going to base64 encode these bytes in the picture.png file. And when we do that, we get a very uniform character set that we can send across the network without fear that it's going to get in the way of the server software. So this is one of the reasons why we have to use base64 to encode data. But another thing that we can do with the base64 encoding scheme is that we can create fun little puzzles for us to solve, like this. But anyways, let's see, what else do we have? Okay, and we talked about the echo command. So the echo command is used to create output equal to whatever is supplied to it. It can be used to supply input to another command through command piping. So echo is, by itself, echo is not a very useful command, but you use it with other commands to achieve some good output. And we learned about output redirection. So output redirection is a feature in Linux that can be used to direct the output of commands and write that output to a file. So I can give you a little demonstration here. So we've got the picture.png file. If we wanted to move it across a network, we could turn this into base64 encoded information with this command over here that turns it into base64 encoded data. So what we can do is we can command output this to turn all this base64 information into a file. We'll call it picture.b64. So after that, we've got another file called picture.b64. So this is base64 encoded data. What we can do with this file here is we can transform this data back into its original form. And the way we would do that is we would read the file with the base64 encoded data. We would pipe it into base64 decode, which turns it base64 decode, which turns it back into its original bytes. So when we do that, we can do output redirection again to turn it into a picture. So I'll call this pic.png, Okay, and then we got the original information back in pic.png, and we can take a look at it using the xcg open command, and we convert it back into its original form again, like this. So yeah, that's output redirection. All right, so what's next? In the next Linux OS operations workshop, we'll keep learning about Linux commands through the picoctf platform. I'm pretty sure in the next workshop we're going to be talking about terminal text editors. So text editors are something like, there are a few different text editors that that people like to use. For example, there's the Nano text editor, and this is basically a way of editing text. What are we going to text edit today? And we've got NeoVim. I don't think I've got NeoVim installed on here. Nope. We do have the simpler version of NeoVim, which is just called Vim. So the most common text editors on a Linux system are going to be Nano and Vim. So Vim or Vi, yeah. So Vim, this is another text editor. The only thing I teach people to do, the only thing I teach beginners how to do inside of the Vim to start with is I teach them how to exit the program. So to exit the program, it's actually harder than you think. You need to type in the colon, and then you need to type in the word Q. Because otherwise you could get stuck. Sarah says, Vi all day, says Jonah. Sarah says, I want to test Emacs, but it looks complicated. So XR says, I'm still in Vim right now. Just escape 10 times. Hit the escape key 10 times. So, okay, so just do :Q or :Q exclamation point, and that gets you out. So this is actually like a meme inside of the Linux community. People don't know how to escape Vim. Anyways, let's move on to the next topic a little bit earlier. In the Cloud says, I felt like I had a problem with it less than an hour ago. Arch people. Gameboy says, Arch people made it. That makes a lot of sense. Okay, Jonah says, to be fair, first two Vi commands I learned were :W and :Q exclamation point. So :W is going to save your file, and :Q exclamation point is going to quit out of the file. Anyways, let's move on into the next topic. But thank you very much for watching today's HackerFrogs AfterSchool. We're going to be back next time. It is, what day is it today? It's Friday. TGIF, everybody. We're going to be back on Monday, and we're going to be learning more Linux stuff. So come back at the same time we did today, and we'll be doing that. Let's do the next topic. So topic 2 is done. Topic 3 is here, and topic 4 is on deck. Ooh, wait. Topic 3 is here. Yeah. So we're going to be covering this game over here. It's called MicroCorruption.com. Thank you very much, Arthur Art, for subscribing on YouTube. Thank you. All right, so this is going to be, well, I've never used this platform before, so it's new to me. We've got some ads running on Twitch right now, so I'll run them on YouTube. And I'll put on some birds. Okay, enjoy the birds. We'll be back in about 20 seconds. Just need to have a little sip of water. If you don't know what the vibe is with these birds right here, I'm pretty sure these are sibling birds. So these are little baby birds. They're brother and sister maybe, and one bird is bullying the other bird. Let's put the birds away though, and we'll get back to the hacking. Okay, so this is the MicroCorruption website, and we're going to start from the very beginning here.
Is this a hacking?
Defus redeemed, is this a hacking? Anytime you're typing on the terminal, you're doing a hacking. So microcorruption.com, it's a very well-known website that teaches assembly language concepts and reverse engineering. Let's read about what the concept of the game is. So it says, scattered throughout the world in locked warehouses are briefcases filled with Yombinator bearer bonds that could be worth billions, billions of dollars. You will help steal the briefcases. Yombinator has cleverly protected the warehouses with lock-it-all electronic lock devices. Lock-it-all locks are unlockable with an app. We've positioned operatives near each of the warehouses. Each is waiting for you to successfully unlock the warehouse by tricking out the locks. The Lock-it-all devices work by accepting Bluetooth connections from the Lock-it-all Lock-it Pro app. We've done the hard work for you. We've spent $15,000 on a development kit that includes remote-controlled locks for you to practice on, and reverse engineered enough of it to build a primitive debugger. Using the debugger, you will be able to single-step the lock code, set breakpoints, and examine memory on your own test instance of the lock. You'll use the debugger to find an input that unlocks the test lock and then replay it to the real lock. Should be a milk run. Good luck. We'll see you on a beach in St. Tropez once you're done. Okay, so I guess we can click on the link. It says start here. And right now we're going to do the tutorial. Okay, let's see if we can make this a bit bigger. Okay. So we got a tutorial. So this tutorial will step you through our debugger and explain how everything works by showing you how to beat this level. It is strongly recommended you go through it. It'll take less than 15 minutes, we promise, but it's not required. You can always return to this tutorial if you choose not to by reloading the page. Okay, we'll go next. Okay, so we read this already, so we're just going to skip this. So this is the disassembled object file. It has all the instructions that the Lock-it Pro will execute. Scroll around to view the instructions. Okay, so these are the instructions here. You're going to notice that these are assembly language instructions. The type of instructions that you see in this assembly language are kind of similar to the instructions that you'll see in x86 assembly, but every assembly language is slightly different. Okay, let's go down. So this is the debugger input. Enter your commands. Start by typing help. So we'll type help. This is the debugger console. It contains the output of the commands that you enter. Scroll back and read through the help. So we got the help over here. Okay, it says run the program. Type either continue or C to start. So C. This is the I/O console. You will see the output of the lock. In this case, it wants us to enter the password. Okay. The CPU has requested user input from the console. Below is the output displayed on the console. Okay. You can enter input to the console here, which the lock will be able to read. Start by entering test and clicking send. So test. Press C to continue. C. The CPU output goes here too. So enter the password to continue. Invalid password, try again. So notice that the output of the CPU is shown here as well. In this case, the password you entered was not correct. Okay, great. Next. This means the program is finished executing. What means that it's finished? Okay. Let's put an hour on the clock, and we'll do this for the next hour. After the hour is up, we'll be moving on to the next topic. Okay, reset the CPU. So let's try this again, but this time step through the CPU to see what's going on. Type reset to reset the CPU state. Okay, so we'll type reset. In order to see what's going on, we're going to set a breakpoint. This stops CPU execution when a specific location is reached. In this case, type break main to break at a function called main. So the main function is where? Where is the main function? Anyways, let's just, okay. Break main. Sarah asks, what's happening? We're just going through the tutorial for this game over here. It's called MicroCorruption.com. If you want to follow along yourself, this is the link over here. And Justin Oldman, hello, nice to see you here. We're just figuring out the tutorial for this reverse engineering game. So now that the breakpoint is set, type C to continue. So C. The CPU is paused. So you can see the breakpoint was set by the blue background. So, oh, okay. We see that the main function is over here, okay? Remove the breakpoint by clicking the instruction. So the next time you run the program, the CPU won't stop here. You can add any breakpoint by clicking on an instruction, but not during the tutorial. Okay, so we'll click on this thing to delete the breakpoint. These are the registers. Okay, so we got registers over here. This is something that's that's common to reverse engineering and binary hacking stuff. So the CPU registers usually have data inside of them. They show the state of the CPU at the time of the breakpoint. Okay, so it's these values here. So there's a PC register, an SP register, an SR register, etc., etc. So these different registers can hold little bits of information. Okay, next. So it shows the address of the currently running instruction. Okay, notice that it is shown in base 16. All numbers in the debugger are base 16. So when we're talking about base 16, we're talking about hexadecimal. And hexadecimal notation it's basically all of, let's see, let me demonstrate. Hexadecimal numbers. So hexadecimal numbers are base 16, which means that all of your, let me type it out here. So the numbers go 1, 2, 3, 4, 5, 6, 7, 8, 9, A. Actually, it starts at 0, so we should go 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So when we get to A is actually the number 10, B is the number 11, C is the number 12, D is the number 13, E is the number 14, and F is the number 15. So it's called base 16 because including the number 0, it is 16 characters. But I think most of the people here already know how to do hexadecimal numbers. But just keep in mind that when we're dealing with computer memory, we often are looking at hexadecimal numbers. Okay. So this is the current instruction. So the instruction at the program counter is shown here. You can also see it in the instruction listing on the left. So it says current instruction is add this value to SP. Add this value to SP. And we can also see the instruction over here. Okay. So step the CPU. So let's run the program by one step. Type step or S. So S. We ran one instruction. So the instruction we're on, the red one, is the one after where the breakpoint was set. We've moved one step. Okay. Next. Step many. Stepping one instruction at a time can be very slow. type step 5a to step a bunch of instructions. So remember that this number is base 16. We're actually going to step 90 instructions. So each time we see a number here, so in the second slot, this is 16. So it's 16 times 5 plus 10. 16 times 5 plus 10, I guess that's 90. Okay, so we do step 5a. Okay, and let's see. This is the int function. Where is that? Oh, this is the int function. So we can tell that this is the int function because they've got a little label up here. This is how the lock interacts with the user. By issuing interrupts, the lock can put characters, request input, or do just about anything else. Okay. The partial output of the program is shown here. So as we see the words ENTE, part of enter, probably. Continue again. Type continue to run until you're asked for a password. So C for continue. Okay, so it's going to ask us for the password here. You still don't know the password, but let's enter a password to see what's going on. Put test again. So we type in test. Stepping out. You can step out the current function. You can step out the current function by typing out. This runs until it counters the next RET return instruction. All functions end with the ret instruction to return them to the caller. Okay, so we're going to give the out command. Yeah. So you're not yet at the main level, so step out can be abbreviated F for finish. Use that instead. So F to finish. Do it one more time. Okay. The check password function looks interesting. So let's see, where is that? Check password. This is the name of the function here. Okay. Okay, so let's next set a breakpoint here by typing break check password. So we're going to set a breakpoint for the check password function. Type C to continue. So we set a breakpoint for check password right over here. You can tell because there's this blue line over here. Type C to continue. Okay, so let's see. This looks promising. It looks like this is what checks your password to see if it's correct. So this function here, yeah, next. Parsing an instruction. The next instruction to execute is move.b at R15, R14. So this means move whatever is at memory addressed by R15 into R14. Look at the value of R15. So we've got the different registers. R15, the contents are this. So it's hex 439C. So that means that 439C is going to be moved into the R14 register. So R14 is over here. It's currently hex 02. Okay, so remember the value of R15. Remember it's hex 439C in memory. Notice how the password you entered is here. Okay, so where is it? Oh, test. Yeah, so test is here. This is what we put in for the password. Okay, try it. Take a step, type S to watch the CPU move that value into R14. Okay, so we need to watch the register state and the current instruction. So if this is what is actually going on, then we're going to see R14. It's going to be it's going to have this value over here, 439C. Notice that register 14 has changed. Hex 74 is the hex value of the character T. Hex 74 is the value of the character T. So we're talking about hex to ASCII. So we've got hexadecimal, and we do 74, and then we convert it to ASCII characters. Then we get the letter T over here. Okay, hex 74. This isn't what I expected. I expected that this would be moved into here. Huh. Okay, now take another step to watch the next instruction. This one is going to add 1 to R15. Okay, so the next instruction is increment R15. So INC stands for increment. It means that the number is going to go up by 1. So R15 currently has 439C. So I predict that this is going to become 439D. But let's see what happens. So type S. Okay, so now it's 439D. So notice that R15 is incremented. Okay. So the next instruction is going to add 1 to R12. Take a step, type S to watch it do that. It's going to add 1 to R12. So increment R12. So R12 is currently 0. So it's going to become the number 1. Let's see if that happens. Okay, so R12 does go up by 1. This is what we predicted. Next, the test function will compare the value in R14 with the constant 0. It will then set the flags in the status register accordingly. Okay, so the current instruction is what? Test. TST for test. R14. So it's going to test R14 against 0. So R14 is not 0. It will then set flags in the status register accordingly. Where are the flags? Anyways, it's somewhere in here in the register states. Okay, take a step to watch the comparison. So the jump if not 0 instruction is a conditional jump, which will move the program counter when the 0 flag is not set. When the 0 flag is not set, this one jumps backwards by 8 bytes. So GNZ stands for jump not 0. So it's looking for the 0 flag. Where is the 0 flag? I'm not too sure which one it is here. So is it FB23? No, I don't think it is. This one jumps backwards by 8 bytes. So I guess minus hex 8 means 8 bytes. I'm not too sure what the $sign here is, but it's probably something specific to this assembly language. Okay. Mouse over it to look at the flags that are set. What? The C means that the carry flag is set. If the result of the last instruction was 0, then the 0 flag would be set. It's not, though. Okay. So another jump, let's see it jump type S. So we're just going to observe how we jump back 8 bytes. So we jump back 8 bytes. Does it move back in instructions, or what moves? Type S. But remember, we processed 1 byte of input and incremented R12 along the way. So the current instruction is move B, R14, R15, R14. What's move B? Okay. Eventually the loop will end. So when it happens that R14 is 0, the jump won't occur, and we will end at address hex 448E. Set a breakpoint here with break 448E. Notice that this is a base 16 address. All numbers that you enter into debugger are base 16. So this is all hexadecimal stuff. Break 448E. Okay, so this is the end. You need to unset the other breakpoint. Type unbreak check password. Unbreak check underscore password. Now continue that location. Type C. We don't want this breakpoint anymore. Type unbreak this thing. Okay, so unbreak it. The CMP instruction compare two values. So the compare instruction will compare the value in R12 with the constant 9. Okay? Notice that R12 is 5 right now. This is because we entered a 4-character password with 1 additional character for the null byte. Okay, so this is the length of the password, or the length of the user input that we put in. Okay, step to watch it do that, type S. So the jump equal and jump 0 instruction, jump equal, jump 0 instruction, jump if equal, or jump if 0. So this function will skip forward by 4 bytes if the comparison was true, if R12 was 9. The jump if equal and jump if 0 instructions are actually equivalent. This is because CMP sets the 0 flag when the values are equal. Okay, the 0 flag isn't set, so we don't expect the jump to happen. Type S. See what would have happened if we did jump. Okay? Where are we? So we would have ended up here at address 4498. Where is this 4498? It looks like it's covering it up. Can we drag this? We can't drag this window. I wish we could. Can we? Okay. We end up there. Sure. Change the program counter. So type let PC equals 4498 to change where the program pointer counts to. Program counter points to. All right, let program counter equal 4498. Step out, type out or F to see what's going to happen next. So out. We're running a test instruction again. It checks if R15 is non-zero and sets the status flag accordingly. So we got the test instruction, test R15 for not 0. Test, okay. Watch the instruction run, type step. We know that R15 was 1. And the jump happens when the value isn't 0. Step again, type S. So jump non-zero. So this jump is going to happen. And it's going to jump forward by this number of instructions. So main plus hex 26. Okay. Done. We're moving the access granted string. Then calling puts, and then calling unlock door. That means we're done. Okay, continue the CPU execution with C. C for continue. But remember, we cheated by moving the program counter to the instruction we wanted. Let's do it again, but with the correct password this time. Okay, door unlocked. If you were not connected to the debug lock, if you were not connected to the debug lock, the door would now be open. Try running solve in the debug console to see if the solution works with the debugger attached. Okay, what are we doing? Reset the state of the CPU, type reset and start again. So reset. Start up the CPU by going to the input prompt, type C. This checkbox lets you enter hex encoded values for when you need to enter special characters. For example, you would type these numbers instead of test after checking this box. So check here if entering hex encoded input. So remember that these characters right here equal test. So this number right here, when converted to ASCII, is equal to the word test. Where are we? Here. Okay. Next. So this button lets you dismiss the pop-up and go back to the debugger to investigate more. You can resume the CPU with continue, which will bring back the pop-up. Remember that R12 needed to be 9, and it incremented once for every character we typed. So +1 for the ending null byte. So we just need to enter an 8-character password. So try password as the input. Okay, so we'll type in password. After you send input to the debugger, the CPU automatically breaks. This makes it easier to debug what's going on. This has happened every time previously too. Okay, so we send input to the debugger, the CPU breaks. To continue to watch everything work. So C for continue. Just remember that this was on the debugger lock. Now let's do the same thing on the real lock and let our operatives into the first warehouse. Okay, to the lock. So now we're going to execute it on the real lock. Type solve to end the tutorial and do that. You won't be able to run any debug commands, just enter the solution. Okay, so enter the password to continue. So are we supposed to enter password? Door unlocked. So if you're not connected to the debug lock, the door would now be open. Let's try running solve in the debug console to see if the solution works without the debugger attached. Okay, so we solved it. So let's try to understand what exactly happened there. We'll go back to the tutorial, but we won't actually do the tutorial. I know what I'm doing, just let me go. So we got all this different stuff we need to pay attention to while we're solving these puzzles. So what we want to do is we want to figure out what is being compared. And I think what we need to do is we need to find some instructions that are going to be comparing the passwords. So one thing we need to figure out is what exactly is going on with the assembly language that is being used. So what assembly language does MicroCorruption use? Okay, so we've got a little bit of, let's do a little break. I just need to do a little bit of water. We got the ads running, and it's peanut time for the birds. Okay, we'll be back in about 20 seconds. Just need to take a little water break. Okay, so MicroCorruption. It's a pretty, I'd say, for reverse engineering, for people who don't know reverse engineering, it's really throwing you into the deep end here. Okay, so the AI overview says MicroCorruption uses the MSP430 assembly language, which is the assembly language for the Texas Instruments microcontroller. The game emulates the behavior of this real-world microcontroller. We're doing RE, yeah. Well, we're trying to do RE. It's a tough game, but we're gonna try to learn what exactly we need to do to play the game, because we want to learn about reverse engineering. So the MSP430 assembly language. So key aspects of MSP430 in MicroCorruption, the instruction set. So we'll be working with the specific instructions for this assembly language. And let's see. So what I'm going to do is I'm going to start taking some notes, because every time you want to learn some cybersecurity stuff, you want to take some good notes so that you can come back to the notes when you get stuck. So let's see. HackerFrogs, we'll do a little write-up. So this is going to be a walkthrough for MicroCorruption. Going to do MicroCorruption. Okay, and the name of the file that we're going to be editing here, it's going to be assembly notes, because we need to get a grasp on what the assembly language does. So what is this called? It's called MSP430. So MSP430 assembly language notes. So there's a lot of stuff we need to understand before we can proceed. So the first thing we're going to be learning about is the instructions. So each one of these instructions, we're going to have to learn about them, because there are a lot of common instructions to these assembly languages, but we're just going to get a list of them. So that's MSP430 instruction sets. Instruction set. Okay, we're gonna have to. Oh, UBC. This is from my province. Best way is to use CrackMe rather than this MSP430 controller. Well, I mean, this is the game that we're playing right now. Okay, so we got a list, the complete MSP430 instruction set, 27 core instructions. So we're gonna try to understand what the instructions do. So we're not gonna memorize all of the instructions. We're just gonna pay attention to the instructions that we see in the game. So in the game, we've got these ones over here. Let me rearrange my tabs a little bit. Okay, so we got ret, we've got move, we've got and.b, you got bis. I don't know what these things do. We're going to figure it out. So return is the return instruction. Okay, return from interrupts. So ret, we got more than one, I think. Ret, return from subroutine. Okay, so let's just record this stuff. So ret is return from subroutine. Okay, and what's next? So we'll just take a look at the instructions, just going down the list. So move is probably going to move some value into a register. So the next one is MOV. Okay, so MOV is move source to destination. Move source to destination. So in this case, move something, move A to B. Okay, let's record that. Move is move source to destination. And I guess the example is move one, and what was that? And then comma, and then another register, SP. What are, I mean, we're probably going to need to figure out what these, what SP is as well. But, man, this is a lot of work to play a game. So move one SP. This means move the value 1 to the SP register. Okay. What do we have next? So next is the and .b. So and is the and. Sozo, hello, nice to see you here. What is up? We're trying to play this game over here. It's called MicroCorruption. And we're going to be learning how to use an assembly language to do this. It's a very hardcore reverse engineering game. But I mean, we're really trying to learn about reverse engineering these days because we want to teach a little beginner's course on reverse engineering eventually. But before you can teach something, you have to learn the thing. Just got home from work. Sounds interesting. Yeah, I mean, we're learning a kind of obscure assembly language, but because all the assembly languages are related, we're going to try to figure it out. So the instruction is called AND. So AND is going to be AND is a bitwise operation. So AND is a bitwise operation, destination, source. So where's an example of this? I guess there's an example in the actual game. Get password, check password, unlock door. I mean, we're just gonna slowly go through this. We're probably not gonna do make a lot of progress this in the next 25 minutes, but we're gonna be studying these instructions to figure out what they're doing. We can set our breakpoints by clicking on the instructions. So that's pretty convenient. So the great thing about assembly instructions is that you can ask the AI to help you explain these things. There's no shame in asking the AI to help explain like programming languages. So we are learning the what is it called? MSP 430 assembly language. What does this instruction do? So we got this one. Okay, so the instruction clears all the bits in the lower byte of the register R5, setting it to 0. It's a very common and efficient way to zero out a byte. It clears all the bits in the lower byte of the register R5, setting it to 0. So R5, I recognize this. This is the R5 register. And how does it do a 0 out? So AND B is the operation. So AND is the logical AND operation. B is the byte suffix. So whenever we see .b, we're talking about bytes. So this means that the operation will only affect the lowest 8 bytes. So the upper 8 bytes of R5 will remain unchanged. How? The operation will only affect the lowest 8 bytes. The least significant byte of the register. So this is the source operand, an immediate value, a constant number encoded directly into the instruction. The source operand, so hash signifies an immediate value, minus hex 1. So this means hex is represented in hexadecimal, okay? So this is the operand, destination operand R5. The AND operation will be performed between our immediate value, -1, and the current value of R5. The result will then be stored back into R5. MD explains, hello, nice to see you here. Okay, so key understanding, the -1 and the 2's complement. So the magic here is that -1 what this looks like in the computer's memory. Listen, MD explains, don't type strange messages in the chat. The next time I think that you've got too many strange messages in the chat, I'm just gonna ban you, okay? My machine broke too early today. Machine. I'm not too sure what you mean by machine. Magic here is that -1 looks what it looks like in the computer memory, which uses 2's complement notation. Okay, so in an 8-bit system, -1 is represented by all the bits being 1. So -1 means all the bits are 1, which means FF and hex. How the AND operation works. The logical AND operation follows a simple rule. The output is 1 only if both of the inputs are 1. So A and B result, so 0 and 0 equals 0, 0 and 1 equals 0, 1 and 0 equals 0, 1 and 1 equals 1. So in this bitwise operation, both of the bits have to be 1. Okay, so Nuruddin asks, can we do reverse engineering with Copilot? You could ask Copilot to do reverse engineering. I mean, how accurate it is, I'm not sure. If you're learning reverse engineering, you shouldn't only use the AI to teach you. You should also be taking some sort of course. The AI is very good at helping explain things, but you should use another source when you're trying to learn about any one of these topics. Emin says, I think Claude is better as an AI for this kind of stuff. They say that Claude AI is better at coding, but I'm not sure. So let's apply this. Since the source operand is -1, which is 11111 for everything. Okay, Noradine says, can you do a live session of trying it out and show us how we could learn along? I mean, I'm trying to teach myself how to use this assembly language over here. It's new to me, and this is called MSP 430 instruction set. I think, well, I mean, we could probably get a Wikipedia article for it as well. So MSP 430. So this is a microcontroller from Texas Instruments, and it's a pretty old family of microcontrollers. Okay, where are we? So okay. So since the original operand is -1, the operand becomes R4 bits. So it's going to fill up the lower bits. So the upper register, this is a 16-bit register, the R5. We've got everything in the upper register here, and the lower register, which is Y. So if we run AND with -1, so the B suffix means that we only use the lower 8 bits of this. So MSP 430, it's Motorola, right? I mean, it says it's Texas Instruments. So not, I don't think it's Motorola. So the result is going to be that the upper register is, whatever was in the upper register, it stays the same for R5, but everything in the lower register is going to be zeroed out. So the upper bytes of R5 is ANDed with the upper bytes of their constant. However, because we use the .b suffix, the upper byte operation is suppressed. The hardware ensures that only the lower bytes are modified. The lower bytes of R5 are ANDed with this over here. So any byte 0 or 1 and 1 results in the original bit. So YYYY and 1111 results in everything. This seems like it would do nothing. Okay. Gameboy says, I got a virus TI with MSP chip. Where did you get that? Okay, the correct explanation involving sign extension. The critical detail is that the MSP 430's immediate value for a byte instruction is still a 16-bit value. Before the CPU performs the 8-bit AND operation, it sign extends the 8-bit immediate value to 16 bits. So the immediate value -1 is hex FF as an 8-bit number. It was a synth for Music Virus. Music Virus? I've never heard of this. To sign extend it to 16 bits, the CPU copies the most significant bit, which is 1, into all the upper bits. So now the .b suffix tells the CPU only write the lower 8 bits of the result back to R5. Leave the upper 8 bits alone. So the actual operand is Cloretto. Hello, nice to see you here. And it looks like a Brazilian flag. Welcome, welcome from Brazil. Thank you very much for coming by. Okay, so logically AND the 16-bit value, FFFF, within the full 8-bit value of R5. So because of the .b suffix, only the lower 8 bits are affected, are written back. So the upper 8 bits are unchanged. Okay. What is the bit results of R5 and FFFF? It's just the original value of R5. It remains unchanged. What? But then what is written back to the lower bytes of R5? The lower byte of the result, which is the original lower byte of R5, this still seems like it does nothing. What is going on? The final piece, the constant generator. So the MSP 430 has a powerful feature called the constant generator, CG1 and CG2. To save code space and time, common constants like hex 0, hex 1, hex 2, hex 4, hex 8, and hex FFFF are not stored as full 16-bit immediates in the instruction. Instead, a special register is used to generate them. The instruction and .b is actually assembled using the constant generator for... Well, that is cool. At the end, it did nothing. Well, I mean, I don't think it actually does nothing. So, however, the true behavior when the constant generator provides this for the byte operation is to supply 00FF instead. This is the crucial detail. The CPU effectively performs hex FF R5, and we know that any byte and FF results in any byte, this still does nothing. what what the actual is going on? So there's one last layer for byte operations. The constant hex FF provided by the generator is actually considered a positive value, plus 255, and not a negative value, which we typed. The sign extension process does not occur for this position value. Is the AI going crazy? The explanation it's giving is not. I don't understand what the heck is going on. So this is a special case. The assembler translates this into instruction that uses the constant generator to produce the operator. The operation then becomes lower byte. The result of the operation is to the original lower byte of R5. The instruction effectively does nothing to the contents of R5. It is a no operation for the lower byte. It is important to know that if the intended purpose of writing this is to clear the byte, this is a very common mistake. You know what? Let's ask another AI what this instruction does. How to actually clear the byte the correct way. To zero out the lower byte of R5, you can use one of these methods. So move hash 0 R5. Okay, move the value 0 into the lower byte of R5. BIC bit clear clears all the bits in the lower byte that are set to 1. And then AND 0 with R5. ANDing anything with 0 always results in 0. Oh, you know what? Let's ask another AI. We'll ask Claude, and hopefully Claude gets us a better answer. Start a new chat. Okay, copy that. Okay, so we are learning about the MSP 430 assembly language. What does this instruction do? Okay, this assembly instruction performs a bitwise AND operation to the lower byte of register R5. So it is the lower byte. So I guess this small b means the lower byte of the register. Okay. So this is the immediate source operand. -1 in 2's complement is FF, all bits set to 1. So this is the destination in one of the operands. What it actually does. So this instruction clears the upper... What? This instruction clears the upper byte of the register R5 while preserving the lower byte unchanged. Since you are ANDing with this, so hex FF, all ones in the lower 8 bytes, the lower bytes remain the same, but since MSP 430 registers are 16 bits, this operation effectively zeroes out the bits of 8 to 15 of R5. So this gave us the opposite answer than DeepSeek. So if R5 initially contained this, then R5 would contain this at the end. So it basically leaves the lower half of the register alone, but it zeroes out the upper half of the register, which is the first 2 digits. Okay, let me figure out if this is actually what happens inside of the application here. So how do we reset? So help reset the state of the debugger. Okay, so reset. And then we can step. So the current instruction is going to be move into SP. Okay, so I know DeepSeek is a baby. Is it? I don't know. we can step through the instructions one at a time. So by typing S for step. So step. Now we're going to be moving this into R5. So what is this then? Okay, let's try asking about this. What is this instruction? So I think I understand that we're moving something into R5, but I don't understand the and symbol in this case. I know we're moving some sort of value into the R5 register, but I don't know what the and part means, but let's get an explanation. Okay, so it moves data from a memory location into the register R5. Oh, this is a memory location. So the source operand uses the absolute addressing mode. The AND symbol indicates absolute addressing, meaning it will access the memory location at address hex 015C. Okay, so if this is true, then we need to take a look at what is in hex 015C. So 015C has, we can't see it. Zero 15C. So 01 015C is going to be, are we going from left to right or from right to left? So we actually can't see 015C in the memory dump. So that's kind of, we can't see what's there. If we take a look at the instructions here, 015C is also not here. Okay, let's move on. So the source operand uses absolute addressing mode, the AND symbol. Okay, this is the destination register. What it does is it reads the 16-bit value stored at the memory address 015C and copies it into register 5, R5. Okay, so let's pretend. Let's pretend that that we understand what's going on. So it says here that move something to R5. So R5 here, there's nothing here right now. So we'll step through. And now R5 is what? So R5 is 0 still. What is the point of this instruction? What is the actual point of the instruction? Okay, so then the next instruction is going to be the AND instruction in R5. So R5 already has 0 in it right now. Okay, we got ads running on Twitch. We'll add one run on YouTube, and we'll put on some birds. Okay, we'll be back in about 30 seconds. Just need to take a little water break. Okay, so Nuruddin says maybe you need to use the console to view the value. So where is the console? So this is the debugger value, and can we view a value? I don't see it. List of types. Okay, So we're going to figure out what the what this AND instruction does. So the AND instruction should, if we're listening to Claude, it should actually zero out the upper register. But the upper register for R5 is already zeroed out, which means it does nothing. So this is the instruction here. R5, if it's going to do what we think it's going to do, this actually doesn't change the value of R5. So step through. So R5 is not affected. There's nothing happened. Okay, so the next instruction is BIS. I don't know what BIS is. I guess we can ask what BIS is, because this is all very new. It's like learning like a whole new alphabet. Okay, what about this instruction? So BIS, I've never encountered something like this before. We'll figure out what this is. It's a bitwise. Oh, okay. This is an OR operation. So it performs a bitwise OR operation between an immediate value and the register R5. So we're still doing stuff to the R5 register. So bitwise OR operation. So I should probably take some notes. So this is BIS is a bitwise OR operation. For example, BIS okay, so this is a bit set instruction, which performs a bitwise OR operation. This is the immediate source operand. So hash symbol indicates immediate addressing. So whatever's in this address. So the data that's in this address, which is 5A08, R5 is both the second operand and the destination. So it does R5 or this. This sets makes equal to 1 specific bits in R5 without affecting the other bits. Looking at this in binary, so it's going to be this value, so this binary number here. So bits that are 1 will be set to 1 in R5 regardless of their original state, and bits that are 0 will remain unchanged. Okay, so this is setting bits to 1. So BIS R5 something value something R5 hex. What was that value? Belphegor says, do you have any tools to bypass web application firewalls? I haven't encountered web application firewalls very much, but let's see. We could probably look up something like, what is it? So it's hack tricks, no, hacker recipes. Hacker recipes, web application firewall. Okay, so let's see. Web application firewalls. Here's an article that talks about it. That's a very ugly link. Let me get you a better looking link. This is the better looking link. Sorry about that. Okay, so many web applications stand behind a web application firewall that aims to protect the app from different types of attacks, so such as XSS and SQL injection. By monitoring and filtering requests, so identifying if a WAF is used, what type it is, can bypass known filters. So this can be done with tools like WAF Woof, What WAF, or Nmap. So they've got some tools over here that can help you out. So WAF Woof, What WAF, and Nmap. So just go to this page and look up the tools over here. Okay, everybody, we're going to be switching up topics. Unfortunately, we weren't able to make too much progress in the game because it seems like to play the game you need to know the assembly language already. That's the language of my dog. WAF Woof sounds like a good combination. Okay, so the next time we do this, we're gonna have to educate ourselves on this assembly language first. But it's good to know that this game exists. It's probably a little bit too complicated for us to work through with our current knowledge, but it's something we'll need to come back to. Anyways, thanks for coming with me on this little journey, talking about the MicroCorruption game. So once again, if you want to check it out yourself, this is the link. Bad Thumbs, thank you very much for the subscription on YouTube. Let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get in.
Okay, so we might come back to this later, but we're going to be doing some more familiar reverse engineering and binary hacking stuff. And that's going to be over at the OLIcyber website. So the website's in Italian. It's okay, because we can always do some... Too much for the small brain. No worries, no worries. Your brain starts small, but it can get bigger with exercise. So exercise your brain. And let's improve. Maybe we can build a bigger brain. So these are the challenges over here. XR says, I smell smoke. I think my brain gears couldn't keep up. Listen. I was also struggling to understand what exactly was going on in that game. Love these Italian challenges. So yeah, I mean the challenges are in Italian. The website's in Italian, but these are good challenges. These are good challenges. We can solve them. We can work out our cybersecurity brain. Let me put on some music. How about this one? Okay, so let's do some software security. So software security, that's a catch-all in this CTF game for reverse engineering and binary hacking. And what we're going to do is we're just going to do some easy challenges first to get our confidence back, because it sure was not a lot of fun. Let's see. XR says, I'm definitely bookmarking this site to hurt my head again later. Are you talking about MicroCorruption? Okay, so we got software architecture, we got software libraries, and we got software something else. Not too sure what this is. We'll do this first challenge over here. This is challenge 255. So I haven't been doing a lot of walkthroughs for these challenges. I should probably do some walkthroughs for the challenges, just so we're keeping ourselves honest. So this is OLIcyber, and so this is software stuff. Let's make a new directory. So we'll call this software hacking, because that's what they like to call it. And what is the name of this challenge? The name of this challenge is Software 1 Architecture. Of course, we like to put all of these underscores in here, because I don't like spaces. Okay, this is going to be Markdown. So there are a number of things we need to record when we do our walkthroughs. We need to record the URL of the challenge and then a few other things. So where are we? Here. So this is the URL. The concept of the challenge, we need to record that, and we need to record the method of solving the challenge. Okay, so let's start the challenge. So this is challenge 255. And we've got a lot of Italian. So the good thing is that when we encounter languages that we don't know, we can just translate it. So I'm just going to copy all this. We're going to go over to Google Translate, and then we're going to get the description for the challenge. So this is Italian. Where's the I? There it is. Okay, so this is... In this series of challenges, we'll introduce the basics needed to tackle challenges that fall into reverse engineering and pwn, also known as binary challenges. In reversing challenges, you'll be asked to analyze a program, understand how it works, and find a hidden flag. Use AI. I don't want to use AI too much. I'll use AI where I need to. The thing is that the Google Translate site is also AI. This is also AI. It's just a very specialized AI. Okay, so what do they want us to do? In this first challenge, you'll be asked to find the architecture of the ELF file. So the flag format is flag architecture. Flag architecture? I mean, it seems like it would be pretty easy. Okay, let's go back to the challenge. So the challenge here, we've got a binary file that we need to download. So I'm just going to copy this. I'll provide everybody with a link just in case you want to do this challenge yourself. So in our Linux console here, let's download the file. What? Redirecting output to wget log. Why? Hold on, I think it might be because of the special characters here. Yeah, okay. Special characters. Oh, it doesn't like that. It doesn't like wget. Okay. Let me just click on the thing, and it'll be downloaded to the downloads directory. Okay, so it's called SW1, right? SW01. So all we need to do is run the file command on this. And this is ARM. So this is an ARM architecture. So are they looking for ARM? So the format is going to be flag architecture. So copy that, paste this in, and so is it just ARM like that? So AArch64. So they might be looking for this. I'll try providing this as the flag. See if it works. Wrong flag. Okay. Let's just translate this. In the first challenge, you were prompted to find the ELF file architecture. Okay, Sis32Dream says, been a while since I've watched. What do you all think of TryHackMe? TryHackMe is a good platform. They've got a lot of good stuff for beginners. Unfortunately, it can be sometimes it's a bit difficult to navigate. Okay, so I mean, I can get you the link, but I don't know if you can use the link. Because it might be, you might have to log in yourself. I'm pretty sure that the link's not going to work for everybody. Okay, so the architecture, I mean, what else can we do? We can probably run Robin 2. Yeah, so we'll run Robin 2 on the file here. So the architecture is, it says ARM. Maybe they're looking for this machine, ARM Arch AArch64. So if that's the case, we'll change this to ARM AArch64, submit. Wrong flag, still the wrong flag. So this is not the right flag. Are we just looking for AArch64? They're looking for AArch64, okay. Did you used to use TryHackMe? Yeah, I mean we still use TryHackMe. We're not using it right now, but TryHackMe, it's a good platform, like I said. Elpheus de Skyrim Elfonto Elfino. That's a lot of elf. Thank you very much for the subscription. Let's give you a Hack the Planet. Actually, let's give you Frog Song. Welcome to the stream. Okay, so what are we doing in this challenge? So the concept is determine the architecture of the binary file. So method of solve. All we need to do in this challenge is download the file, use the file command to get the architecture. That would be file SW01. The answer is AArch something something. AArch64. Okay, then we will commit those changes and we're finished with this challenge. Alright, so create software 1 architecture. Yeah, next challenge. Let's move on to software 2 library. This is the name of the challenge. Okay, so let's create the write-up file. So we're just going to replace the spaces here with some underscores, and then we'll proceed. Okay, the URL, the challenge, the concept, method of solve. All right, this is the challenge we're looking at right now.
What are you?
I'm system root.
Thank you very much, Sozo, for redeeming I'm root. I guess we rooted the last challenge. It wasn't a super difficult one, so I wouldn't say that it's something we need to feel super proud of. Anyways, let's check out the challenge. So in this challenge, this looks like a new tool that I haven't used before. So it's interesting that what I really like about this website is that they do a lot of teaching, and I really appreciate that. So inside of the description, they teach you about how you should solve the challenge. So dynamically linked binaries need to search the system for the libraries that they need. Knowing how to find the dependencies can be useful. In particular, this binary tries to load some strange libraries, which ones? So try LDD, a tool that lets you list the shared libraries required by a binary file. I didn't know about this tool before. Cypher says, I feel like Try Hack Me is releasing less free machines, and less of them are pen testing challenges, and more of them are forensics and things. Forensics and things now. I mean, Try Hack Me, yeah, they used to do a lot more free stuff, and then they used to do a lot more challenges. But I guess that's the nature of what they're up to. OreoBite, hey, hello, nice to see you here. Hey, OreoBite, if you want to join along with us, we're covering a bunch of binary challenges. Well, software challenges from the platform here, the Italian platform. So we're just running down the list for the software security section in the introduction. So they're introducing us to the LDD tool. I've never used this one before. So let's see, LDD, it exists. I've never used it, but apparently it lets you list out the linked libraries that a binary uses. Okay, so what are we doing? So the challenge here, we're going to download the attachment. So software 2. Cypher says everything good ends up locking free users out somehow sooner or later. So have you checked out Pwn College? Yeah, Pwn College is actually, it's probably the best place to learn about reverse engineering and binary hacking. So pwn.college. Am I logged in here? Yeah, okay, I'm logged in. So they've got a lot of good stuff, especially if you're learning about reverse engineering and binary hacking. But they've got a lot of good stuff for other stuff as well. But so, for example, if you want to learn about, I don't know, program security, you could enter any one of these little challenges over here. I'd love to cover them on stream, but it's not allowed. The people at Pwn College, they don't allow people to live stream their stuff, and they don't allow people to make YouTube videos out of their stuff, because they don't want the answers to the challenges out there. So let's, yeah, unfortunately, it is a very good place. It's a very good place to learn this stuff. Amin says, can you give us all those CTF challenges? So all the CTF challenges? I mean, I'm pretty sure I've got quite a few of them on the HackerFrogs GitHub. Let's see, education resources. I don't have it yet. So the CTF challenges, I don't have a list of that stuff yet. I should probably make up a list of all the stuff that we use. But for right now, I don't think we have a list of them. But the challenges we're doing right now, they're all over here. Okay, so let's go ahead and solve the challenge. So over here, we've got software 2, software 3. Which one do we download? This is software 2. Okay, so I guess what we need to do is, Frank Reben says ethical hacking. Yeah, we're doing ethical hacking stuff over here. We're just solving challenges on the CTF website. It's the training.olicyber.it. You should see it in the chat. Okay, so what we need to do is we need to figure out the linked libraries for SW02. This is really funny. Okay. So the linked libraries, we got Linux well, you know, these libraries here, but there's also got flag something something. So we can probably do some Linux foo. Or everybody says, I guess I'll jump in, but I have to play catch up. You don't need to catch up very much. We only did one challenge. So we're just going through the list. Let me point it out. So we've got the software security under the introduction. So this is the introduction zone. Software security has 20 challenges. We've done challenge 1, challenge 4, challenge 7, and challenge 8. It's not... I'm pretty sure that none of these challenges are super difficult, but it's good to go through the basics. So we're currently on this challenge right over here, Software 02. So LDD. So we got the flag over here. What we want to do is we want to use Linux foo to output just the flag. So how do we do that? First of all, let's cut D, cut by delimiter space, and return field 1. So that results in this. The next thing we want to do is we want to eliminate everything that on the line that has more than one character. How do we do that? So this is where we figure it out. Linux delete lines with more than one character. To delete lines in a Linux file that contain more than one character, you can use sed or awk. Using sed, you get the I option that modifies the file in place, regular expression, that matches with 2 or more characters. So the D command deletes the matched lines. Oh boy, I love using sed. No input files. No input files. Can't we just do it on standard out? Using awk. The awk command can filter lines based on their length. So awk length. Why do we have to do it like this? Can we do it like this? Okay. So we're slowly using our Linux foo to get the flag. All right, let's we got an ad running on Twitch, so we'll run one on YouTube. And here are some birds. Here's a lovely bird. We'll be back in about 60 seconds. Just need to have a little water break. Piping, yeah, we're doing piping. And then pipe TRD new lines. Yeah, that makes a lot of sense. Okay, put the birds away. And then tr delete new lines. And then finally tr delete spaces. Hold on. Doesn't this delete spaces? Maybe we delete the spaces first. Delete the spaces and then delete the new lines. Yeah, I mean, it looks like maybe there are tabs. How do we delete tabs? Linux delete tabs. Okay, so tabs, well, we're using tr, oh, /t for tabs. Okay, yeah, thanks everybody. Could be tabs or many spaces. So we'll delete the /t for tabs. Okay, cool. So we just need to delete the tabs and then delete the new lines, and then we get our nice clean flag. Teamwork, yep. Thank you everybody. All right, let's copy this, and we will submit the flag. We got some Linux magic going on. Paste in the flag. We're done. Wrong flag. What? What do you mean wrong flag? I got this flag fair and square. Maybe flag needs to be lowercase. Flag. Flag needs to be lowercase. This is some BS. If they was supposed to be lowercase, why was it not lowercase here? Anyways, let's record the thing. All right, back at the write-up. Concept. Listing out a binaries linked libraries. Okay, the LDD command can be used on a binary to list out its linked libraries. Okay, so this is the command we used. Whoops. Bam, there we go. All right, yeah, we finished this one. Okay, let's move on to the third challenge. So this should be some pretty smooth sailing for at least a little while. Shinobi, hello, nice to see you here. Sezioni. Sezioni, I don't know what the word Sezioni means in Italian. Let's figure this out. Italian, Sezioni. Sections. Okay, so I guess we're going to be talking about sections. Okay, so what is the description? ELFs are composed of several sections. For example, the executable code resides in the .text section, uninitialized global variables are in the BSS section, and so on. Can be useful to know how to list sections present in the ELF file. In particular, this ELF file has a mysterious section. What does it contain? A useful tool for analyzing object files is object dump. The -h option allows you to list the sections of an ELF. Really? Shinobi says, why is there an elf? Why is there a frog on my screen using the computer? Well, it's a magical time. It's a magical time on the internet where you could have all sorts of avatars, and they can look like anything you want, even frogs. Even frogs wearing sunglasses and hats. Will the frogs take our jobs? The frogs aren't going to take your job. The frogs are only going to take the jobs that nobody else wants. Okay, so what are we going to do here? So the challenge is this one. This is the link. Challenge 257. And let's start the write-up. So we'll create a new file. The name of the challenge, let me just get this. .md Sezioni Okay, so we need to list out a few things: the URL of the challenge, the concept for the challenge to solve it, and the method of solve. Before we go on, I'm just going to grab and input the URL. And the concept for this challenge is going to be program sections. or binary sections. I guess binary sections, sure. Okay, so the method of solve. We can, well, first we need to download the file. SW3. I'm pretty sure nobody can use the links, or I'm pretty sure nobody can use these links. Let me know if you can. I don't think you should be able to use these links unless you're actually using my my session. Okay, but anyways, download the file, and so we got S03. So SW03. Is it object dump? Object dump SW03, and they indicated they were supposed to use it with the -H flag. Okay. That's funny. So this lists out all of the sections of the binary, and we've got a super secret section in here. Okay. So how do we read by section then? So object dump --help. Display the section headers. So sections. How do we display the section contents? So we got full contents. Display the full contents of all sections requested. So is it -S and then the name of the section? SW03. So Amin says it works. Okay, so the links work for you? That's great. So where is this one? Super secret section. So do we just supply it here? As a positional argument? Okay, so it looks like it works. Or maybe. Oh no, this displays everything. How do we display only a specified section? Okay, let's look it up. obj dump specific section. Disassemble specific section. How to disassemble one single function using object dump. To disassemble a specific section or of an object file or executable, -x section in conjunction with the -d flag. Okay, so it's -d -j and then the name of the section. So we just do it like this. What am I looking at? Golden Badger says, hurry up and hack the Federal Reserve. We're not going to be hacking any Federal Reserve up on this stream, but thank you very much, Golden Badger. Welcome to the stream. Welcome on in. Let's give you a fun video redeem. What do we have? We've got, let's give you a Jurassic Park.
It's a unit system. I know this. It's all the files of the whole park. It tells you everything.
So we got this super secret section, but so add I'm not exactly sure how we're going to extract the flag from here. Frackery said, how did a little girl know Unix? Well, I mean, you can't underestimate anybody for being young or a girl. That's not cool in this day and age. And I'm pretty sure that most of the best hackers in the world are all like teenagers, right? They have to be. You're all about teenagers hacking into NASA all the time. Okay, so let's go back to the challenge. Okay, this elf has a mysterious section. What does it contain? So this section has these instructions here. So are these... So 41, so that's... we need to figure out how to... Are there strings? We could also run strings on the binary. We could run a bunch of stuff on the binary. How about we run some... Yeah, let's run some strings. So SW03. Okay, so there's the super secret section. Super secret section, it's in here. Yeah. So I guess the important thing to know first is just this part of the command to get the names of the sections. So let's put that in the write-up. So the first thing to do is get the names of the sections in the binary. And I guess this is the command. There is reference to a, what is the name of the thing? Super secret section. Super secret section in the output. The next thing need to do is get the contents of the super secret section. And we do that with this command over here. So the problem is that we need to interpret this code. So the problem this is x86 assembly. It could be that the way I would usually do this is I would inspect the binary using Radare 2. We would do Radare 2 and then inspect the binary here. We would analyze the binary and then we would take a look at the functions. And in the functions, there's going to be the super secret whatever. No, it's not in here. Huh, that's funny. I mean, I guess there is the main function here as well. It's strange. It gets me thinking. Okay, so take a look at the main function. And the main function actually doesn't say very much. But what if we wanted to take a look at the sections in Radare 2? Radare 2 list out sections. Okay, the concept of sections is tied to the implement. Okay, so there's a cheat sheet. show strings, all sections IZZ. IZZ? Okay, MD explains I can't give you a timeout every time you ask me to time you out. You have to control yourself. You can either not type weird stuff in the chat, or you can type weird stuff in the chat and I'm going to ban you. So if you're really tired and you think that anything that you type into the chat is going to be really strange, don't type into the chat or stop watching the stream. Okay, so IZZ. So we got super secret section. These are all the strings. So we got a cheat sheet. Yet another. Now we're down a cheat sheet. Let's see. Let me try asking the AI. I'll ask Claude because Claude seems to be better with coding stuff. Okay, so I want to use Radare 2 to list out all of the sections in a binary. What command do I use? It's thinking. I guess the other thing we need to do is to figure out how to list out the stuff only in that section. So the problem with using a free version of the AI is that sometimes it's not very responsive. You can use the is command to list out all sections in the binary. So it's lowercase is. Okay, Oreobyte says that seems like you also find hidden dot sections with the read elf. So -- header, but it doesn't give you more of the flag. So I mean, is, list out all sections with basic information. is, so I, capital S. Yeah, so this is all of the sections over here. Prog bits. I'm guessing that prog bits is these are the names of the sections. Okay, so I mean, if that's the case, then how do we... So load your binary, analyze it, list sections. So I is for information, S is specifically for the section containing information including addresses, sizes, permissions, and names. Okay, so now we want to use R2 to list everything in a particular section in the binary. Okay, so you can use several approaches to examine the contents of a particular section. So px at section name, px section text, method to section and print. Disassemble if it's code, section pd at section.text. Okay, so let's try this. So pd at section.text. So instead of .text, it's .super secret section. Did I type that in incorrectly? Oh, there's supposed to be 2 dots here. Still doesn't work. Did it give me the wrong command? Print section with the size limit. How about px? So instead of pd, we'll do px. Nope, it can't find it. Well, I mean, we could get the address. We know the address is here. Found the tool with object dump. That tool took longer than it should. So OreoBite, can you tell me about what exactly you did with the object dump? So px at this address here. I mean, this is blank. Okay. Found the flag with object dump. Let's get out of here. So object dump, disassemble. Well, I mean, I guess we're not disassembling it in this case. Mailbox says, need help with the SDK Android emulator in command mode, but just command mode. They keep changing the value. It says it can't find root. I mean, if anybody in chat knows about the SDK Android emulator, please help out Mailbox, because I personally don't know very much about Android emulators. So object dump is -s. So what does the -s thing do? So -s is basically dump the entire thing, right? So this dumps the entire thing, and we grep for what? We grep for .supersecret section. And then we get everything around it. C5. C5. I mean, we don't necessarily need to... Well, okay, C5, that makes sense. But what is this? So contents of the section. So it... Man, why is it like this? Well, I mean, if we wanted to... Can we dump this without... Can we dump this without the addresses here? So, I mean, we got the flag, but it would be nice if we could use some Linux foo to just get the flag. So object dump, I mean, could we also... We could do the same thing by doing... So object dump, sure. Object dump -- help. So -s does full contents. Display the full contents of all sections requested. But we also did the -j. Yeah, no, this is a much easier way to do it. Good old tutorial points to the save. Points to the save. The save? So -s for full dump, and then j is for the section, and then specify super secret section, and then you get just the flag.
But the question is, how do we grep out only the flag contents here? I guess we could do tr and then something something. Tr by space. Hold on. Let me do my write-up. We can dump out only the contents of that section with the following command. I just typed it out. I mean, we're always trying to be like super cool Linux wizards. Hold on. Okay, and then use Linux foo to get only the flag. So how do we do that? MC25 says, can we see the no address? Oh, we can do no address? Hold on. So object dump. Okay, no addresses. Do not print the addresses alongside disassembly. Yeah, that, I mean, let's see if it works. But MC25, thank you. Thank you very much for that contribution. No addresses. Could you jump without the hex? Maybe. So it looks like no addresses doesn't work here. Prefix addresses, print complete addresses alongside assembly. Add offset, show all symbols. Start address, stop address. So I guess no address doesn't work for this, but what if we could cut D by spaces? Return field 1, 2, 3, 4, 5, 6. What? What happened here? What about field 5? Nope. How about field 7? Field 8? Field 8. Field 8 works, but it doesn't get you the full thing. Drive fast. Hello, nice to see you here. I don't think I've seen you in chat before. So we got the flag here. We just need to get rid of everything that isn't... Now we can just save this out to some file, test.txt. And then just do some... Just do this. It's not awesome Linux foo. I wish I could. If anybody has an idea as to how to get that done, let us know. But we can just, you know, do it the line 2 is 4. I have add now I can't see. Oh, sorry about that. Sorry about that. But you know what? Let's just... We use Linux foo to get the flag. I don't think we're doing it. Let's just submit the flag. Move on to the next challenge. That's the wrong flag. You know why it's the wrong flag? It has to be on lowercase. That's why it's the wrong flag. Done. Okay, great. Alright, let's move on to the next section. So we did the software strings 1. We did software strings 1, but we didn't do the write-up for it, so we should probably do the write-up. Okay, let's commit those changes. Let's do software number 4. Software 4, strings 1. Okay. .md. So let's see, the URL, the concept, and the method of solve. Okay, so we'll start out by getting the link for the challenge. The concept is, well, this is going to be strings. And I'll get the link for the binary in case anybody wants to join in. This is it over here. Okay, so I'm pretty sure you just need to run the strings command on the binary. I've got the binary here from last time, so SW04. Just run strings on it. SW04. And then grep for flag. There you go. And I've already solved this, so I don't need to submit the flag again, but let's just complete the write-up. So the method of solve. So we just need to get all the strings. All the strings. Did we do that challenge? No. I'm pretty sure I did that challenge. I'm pretty sure I did that challenge before I told you about the platform. From the binary, it's just strings SW04 and grep for the flag. Done, done, done. Let's move on to the next one. So this one is going to be string 02. No, this is software 5 string 02. Here's the link. Okay, so let's go ahead and start up the write-up. Add file. Okay, so it is URL concept method of solve. So I'm guessing that the concept is more strings, but we'll see. Okay, let me grab the description. We'll translate it. The program for this challenge is similar to the previous one. This time, however, the strings command won't help. To solve these challenges, we almost always need to use more sophisticated tools, such as disassemblers and decompilers such as Ghidra. There are many such as IDA, Radare2, Hopper, and so on. Try Ghidra or your favorite decompiler and analyze the contents of the main function. So, I mean, is object dump going to work on this? You know, we could take a look at this after we download it. Okay. So let's download this. Okay, SW05. So we got SW05 in our directory. So can we run object dump on it? No, let's switch over to Radare 2. So we need to make it executable. Okay, so what we need to do is we need to take a look at the SW05 binary, analyze it, and then take a look at the main function. So print disassembly function at main. What the heck? So there is something that's being loaded in over here. So RAX is going to be object.flag, and it's going to be this thing. So what are these codes? So U something something something. Is that Unicode? I'm not super familiar with this type of encoding. So I'll just ask a question. Yeah. What encoding is this? I think you can use echo to display it. This is Unicode escape sequence notation, so for UTF-16. The flag was right there. Really? Hold on, let's go back. I mean, I'm pretty sure that this is the flag. We just need to decode it. Oh, this is it. Yeah, okay. So this is how many characters? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is 14 characters. So is this 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is that's more than 14 in there. The U flag. Okay, well, I mean, let's try submitting this. Let's try submitting this and see if it works. Okay, valid flag. Awesome. All right, let's do our write-up then. More strings. Method of solve. What we need to do is what? And Gabriel, thank you very much for letting us know that that the flag was right there, and Masterism as well. Much appreciated. Let's do a fun video redeem. How about some... Ooh, what do we got? How about some war games? Actually, no. The Devil's Bedroom.
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom.
Okay, so we can use Radare 2 to inspect the binary. So it's just Radare 2, debug SW05. It's 05, right? Yeah, I'm pretty sure. Okay, so from there, we can analyze and disassemble the main function. Okay, so inside of Radare 2, that's AAA to analyze, and then print disassembly function at main. So we can see the flag string in the instructions. Next to Philistine. Hello, nice to see you here. Welcome to the HackerFrogs. Let's give you some keyboard cat. It's the classic meme that never dies. Okay, so this is next to this instruction right here. Load effective address into RAX object.flag. Where does object.flag get defined though? So many mysteries. Okay, next to these instructions. And that's done. Done like dinner, okay. We'll move on to the next challenge. So the next challenge is going to be strings 3, even more strings. Okay, this is the link, everybody. And let me go ahead and start my write-up over here then. Strings 3. Okay, so URL concept method of solve. So the URL is here. Let me grab it. The concept is even more strings. We don't know how to solve it yet, but we've got our binary over here, and I'll provide the link to everybody if you wanted to do this yourself. Okay, let's take a look at the description. You need to pay a lot of attention to the description because sometimes there's some really important information there. So this challenge is similar to the previous one, except that this time the flag isn't saved in plain text. Analyze the main function with Ghidra and try to understand how the input and flag checks occur. So, okay. Let's download the binary. And then we'll inspect it inside of our favorite program. Okay, and then we will inspect it with Radare 2. And take a look, PDF at main. So what do they want us to pay attention to? Analyze the main function and try to understand how the input and flag checks occur. So the input, we're looking for some instructions. So the instructions, we're looking for, is it called puts or something? This is challenge 6. Yeah, this is challenge 6. I'm pretty sure I put the link in the chat if you want to check it out. Okay, so sorry, we're looking at so the comparison is here. The comparison is here. Load into RSA object flag. So object flag, we need to pay attention to this. We also have a function that lets us do user input. So sim.imp.fgets. So fgets is for getting user input. I'm pretty sure this is for user input. And let's save this instruction right here. We'll set a breakpoint here. So set breakpoint for here and then run the thing. What is the flag? What is the flag? Tests. And then we hit the breakpoint. So we should be right here. So they save our user input. I think they're saving our user input in var 100 110 hex. So we can see what's in this variable by taking a look at the variables. So I think it's AFV. Yeah. So this shows us the variables in the program. So this is the address. It's RBP minus hex 110. And we can take a look at this by px at this address. Yeah, so this is exactly where our user input ends up. So the next thing we need to figure out is what is being compared. So we go back to the main function. We go down to memory compare. So memory compare, this is the C function that does the comparison. And so load into RSI object flag. So object flag is, well, we don't know what object flag is, but it's going to be loaded into RSI. So what we can do is we can set a breakpoint for this instruction right here, which happens right after the object flag is loaded into RSI. So we're going to set a... OreoByte says, gotta go. See you later. See you later, OreoByte. Hope to catch you next time. And yeah, we're probably gonna collaborate on Monday. Have yourself a great weekend. Brew. I'll just call you Brew. Hello, nice to see you here. Welcome to the stream. We're just doing some binary hacking right now. What's happening here? So we're using this website. The website is called OLIcyber.it. It's an Italian site, but we can translate all the text from the website back into English, or not back into English, to English with Google Translate or something. So we're basically, doing these CTF challenges from this Italian website, and we're doing these software challenges. They're basically reverse engineering and binary hacking challenges. We're trying to figure out some secret strings in the binaries here. Okay, so we're gonna keep on running the program. It says Sabagalagi. I don't know how to pronounce this word. What OS are you on there? So we're using Kali Linux. So Kali Linux is the popular cybersecurity distribution of Linux. Wrong, try again. We can try more than once. Okay, so we hit the breakpoint here. And I guess they let you do it twice. That's kind of funny. Okay, so let's take a look at what's in the registers right now. So we know we need to pay attention to the RSI register, because they're loading in the object flag over at RSI. So RSI is going to be the flag. So where is RSI? It's this. So this is EST. EST? Wait, what? Why would it be this? I'm kind of confused. Because object, where are we right now? Hold on. Search the string. Let me take a look at what's in the main function right now. So we're not where I think we are. Yeah. No, we're not where I think we are right now. Okay, thank you very much for following, Brew. Welcome, welcome. Okay, so I guess the flag only gets loaded in if you get the correct word. But what is the correct word? We're currently at this instruction right here. So we do fgets, and string lengths, compare keyword. Compare keyword with var. Compare keyword with 0. Move keyword, compare keyword, jump if equal to something. Jump if equal to here. TechieNut says, which debugger are you using there? Yeah, so TechieNut, welcome to the stream. We're using Radare 2 or R2. It's my preferred debugger for doing binary hacking challenges. It's comparing a string with null, I believe. So cycle through the graph view to see the jumps. Let's see. Graph view, I think it's V? No, capital V. What was the shortcut? Is it H? Hold on. Radar 2. I think it might be Shift V. Shift V. Antonio says, it wants to make sure if the address character is null before dereferencing it and potentially segfaulting it. Okay. It's been a long time since I've done it. Scotty Perky says, what architecture is this? Is this x86, ARM? I'm new to reverse engineering. I've only read ARM assembly internals and reverse engineering by Wiley. This is x80. This is x86. I'm pretty sure this is x86-64, but I can check. Let me check. Yeah, this is x86-64. Cybersecurity says the command is double V. Double V? Cybersecurity hacking seems like another world from what I've seen before, programming related. And by the way, YouTube recommended your channel, so I'm subscribing now. I love low-level content. We're not always doing low-level content. We usually do more low-level content on Fridays. But welcome to the stream. Okay, let's go ahead and put on some different music. Okay, how about some of this? Okay, Let's see. Robinhood says, I still need to figure out how to do the binary pitch diffing. Fast binary pitch patch diffing. Okay, okay. All right, so what are we going to do here? So it's double V. Okay, so I guess we see the jumps over here. Now, how do we switch over to the default view now? Scott Perky, thank you very much for the subscription on YouTube. Let's give you a fun redeem. How about some Stellar Jays? I love these birds. Okay, let's get back to this. Blue Jays, they're not exactly Blue Jays, but they're Stellar Jays. Where07, thank you very much, and thanks for the bits. I'm all about those Jays. They're Stellar's Jays. STLLAR. There you go. Okay, we've got. Oh, we can move around in here too. Yeah, this is very cool. So we can see what happens if we pass the checks or if we don't pass the checks. Do we do escape to exit from here, or is it something else? Yeah, escape. Whoops. Oh, it's Q. Q is going to move us around. Okay, okay. So the Q is to cycle. Yeah, V and Q. All right. So we just need to figure out what the what they're looking for when we do this. So they actually check twice, which I didn't expect. So we're just gonna reset the binary. Okay, we still have a couple of breakpoints, so we're just gonna unset these breakpoints for right now. Okay, we have ads running on Twitch, so we'll run them on YouTube, and we'll put on the birds. This is my favorite bird video. These are the baby Stellar Jays. Enjoy them having a little bath. We will be back in 60 seconds. Robin Hood says, I rather enjoyed cleaning the bird bath and preparing the garden for the birds when I had it. Nice birds you have. Yeah, I mean, enjoy watching the birds having them, taking their little bird baths, but cleaning the bird bath was not my favorite thing. But I appreciate it all the same. All right, let's put the birds away. Get back to the hacking. Okay, so what I want to do is I want to set up a breakpoint to right before the comparison is done. So the comparison is done here. Qual flag, I guess, is what is the flag. So where is the comparison done? So fgets. This fgets
is user input. I'm pretty sure fgets is user input. Then they do the comparison. So the comparison is, they're comparing this thing against 0. Are they checking for the password one character at a time? Compare keyword 120 with E, but E is, hex E is 9, 10, 11, 12, 13. So 13? I'm not completely sure. And then we do... Brew asks, are you streaming right from Kali? No. The Kali Linux machine is a virtual machine, and it's running on top of Windows. So I'm using Windows to do the broadcasting. Kali Linux is just a virtual machine that I'm displaying. Okay, so this is the string that says wrong. Wrong, try again. Prova ancora. Let's double check. Saval Splaglio? Prova ancora. Let me, how do you pronounce that? Splavaglio? Well, I don't know. I don't know how to pronounce Italian. Wrong, try again. Okay. Jug Pearl asks, what's the goal of the labs? Just came. Yeah, so we're doing these Italian labs. So, ooh, it's not it. So the platform that I'm using right now, it's kind of similar to PicoCTF, but it's an Italian platform. You can make an account yourself. You just need to translate the Italian text to English, and then you can use it too. We're currently doing this challenge right here. It's a reverse engineering challenge. We're trying to figure out what the flag, well, first what the password string is, and then what the flag is. So this one's given me a bit of trouble. So the mem comp is the comparison. So object flag. What is object flag? So, I mean, I could skip all of this if I could just figure out what the object flag is. What are they loaded in? Because they have to load in the object flag at some point. Unless object flag is not... Is it at this memory address? If it's at this memory address, then we can just take a look at the flag, right? Should be an RSI. So, I mean, that's... If we can get to this point in the program execution, then we can take a look. But maybe we can just load this up. So if we do px at this memory address, what's in here? I mean, nothing interesting is here. And what is justo? Justo. Justo means correct or something? Let me check. Justo means right. Okay. Okay, well,
So these are... I wonder if it's hard-coded. The answer for the password might be hard-coded. Is object.flag just the wrong correct message? There's a word flag too. So let's try just running strings on this thing. We might be able to see some stuff that we're not supposed to see. La flag, qual flag, splagato, okay, giusto. The only other thing I see is stuff like this. This probably isn't the password we're looking for. Okay, let's go back. So there was one more breakpoint, or at least I thought there was one more. Okay, there are no more breakpoints. Gabriel says, there's the word flag too. Yeah. Here. Yeah, object flag. So where does it say? Where's the string? The string that says wrong and the string that says right. So string qual flag, and there's a string that says right. Giusto, this one. But from the, let's see. Jugpearl says, but from the part where it says you're wrong, can you try to see what above, what it does check? Yeah, so over here we've got a no operation, and we've got a jump. So this one is correct. This one is if you get the thing correct. We got a no operation, and then it jumps over from here. So it's a jump equal to this. Test EAX, EAX. Test EAX against EAX. I mean, that's always going to return true. So I'm still a little bit confused over here. So the one that the other string that we encounter here is the one that that says that you're wrong. So this one says you're wrong, and it says try again, and it's a jump. It's a jump from, wow, it's a jump from way up here. So compare keyword var 120h. So what is in var 120h? I guess what we could do is we can set our breakpoint. So we'll set a breakpoint for this place. And then we can execute the program. What is the flag? Test. We hit the breakpoint, and what we want to do is we want to take a look at the var 120h variable. So I think it's AFV to take a look at where the variables are. So var 120h is RBP minus hex 120h. So print the stuff. This is test. Jugpearl says, I see a mem comparison before the wrong flag. The wrong flag is loaded.
Okay, so mem comparison. I'd peek at every variable. MC25. I mean, that's a good thing to keep track of. So this next one, it's probably not going to be much of a difference, but we'll take a look at it anyways. So peep at that. So it's still not super helpful. Let's take a look at the other variable here. RBP minus 110. So this is just the variable that we set, or the user input that we set for test. Okay, JugPearl says the memory comparison compares a constant and a string, and that is based on the result might load the right or wrong string. So the last variable is var8h. So let's take a look at var8h. We just see a couple of letters. What are the other functions? Okay, so there's the main function, but aside from the main function, there's not really anything super interesting as far as the functions are concerned. Alright, let's go back to where we were before. Oh wait, what is this key object here? Load into RCX object.key. Maybe we should try to figure out what this is. So we'd set up a breakpoint right here, right after it happens, and then take a look at RCX. And we can unset this other breakpoint. Okay, so by the way, very nice content. Well, I mean, I'm trying to work through this stuff. Let's do another. Let's do another 47 minutes, and we'll see what's happening at 47 minutes after right now. All right, so what are we doing? We're running the program. Okay, wrong. What is the flag? Wrong. What is the flag? Wait, does it keep on going? It just keeps on going in a loop. So it'll keep on going in the loop as long as the thing is wrong. I always enjoy low-level, been wanting to watch someone do lockpicking challenges. I mean, I have no idea what I'm doing for lockpicking stuff. It would be fun to do lockpicking challenges, but setting up the camera for that seems a bit tricky. Okay, so let's reset this. Ooh. Yeah. So this is where we are right now. Hold on. No, I guess we've exited the program at this point. So the object key, qualiflag. So it goes back over here. Official Sabu says, can someone give me a beginner-friendly explanation of what's happening? Yeah, we're trying to figure out. We're trying to do some binary hacking. So I must admit that binary hacking isn't super beginner-friendly, but we're currently working off of a non-English website. So that is also kind of not beginner-friendly. But what we're trying to do is we're trying to inspect the binary and all of the program and all the instructions that it's running to try to figure out what exactly is going on inside the program. But Official Sabu, welcome to the stream. If you want to take a look at some more beginner-friendly stuff, we've got beginner-friendly stuff in the first and second hour of today's stream. So we were just talking about some news, and then we were talking about some Linux stuff. It was much more beginner-friendly than what we're doing right now. Okay, MC25 says, IRL lockpicking is also fun, though. True. I wonder if there's anything, like, for software. If there are any games that simulate lockpicking. Hold on, I need a little water break. All right, thank you very much for following Official Sabu. Much appreciated. Okay, so let's go back. Let's take a look at the different views. So Q, VV. So I'm failing to see what's being compared. So qualiflag is a string that's loaded in. What are the other comparisons? So comparisons are going to be either it's going to be memory compare. Where is it? Memcomp here. Gabriel says, here in Argentina we say, let it go, we'll fight it out. Let it go, we'll fight it out. I'm not too sure what expression that is. But Gabriel, welcome. Yeah. What are we talking about here? Okay, so the memory comparison is a comparison here. I'm pretty sure this is the only memory comparison in the main function. We have string length, we've got fgets, we've got printf, we've got memset. And that's all she wrote. So we also have the compare instruction here. Oh, okay. Let it go, we'll fight it out. Oh, it's what's in your throat that won't let you speak. Okay. Awesome. Thank you. Actually, I didn't know about that. But thank you for sharing that. So compare AL. Are we making multiple comparisons? So compare keyword with 0. 0, 1, 0, hex E. Hex E? Are these numbers? I think you're right, it's comparing each letter or number one at a time. Okay, so compare. So are we supposed to supply a number? Let's let's check this one at a time. So the comparisons start here. So compares keyword with 0. So 0, and then this is a jump equal. So if it's equal, it jumps to B340. So B340 is where? Here. Oh, okay, okay. So this is the if it's incorrect. So Bruce says hex E looks like a 16 hex digit, and NG says Ngir. I'm not too sure what that is supposed to be. Hello, nice to see you here on YouTube. What is up? We're doing some binary hacking over here, trying to figure out what the heck is going on. So if it's checking one character at a time, then we can't just load in. We can't just guess. So compare AL with hex A. I'm lost. Do you think it would be easier if we loaded this into Ghidra? It might be. It might be easier if we load this into Ghidra. So let's fire up Ghidra. Ghidra will probably give you better values on things. Maybe? Okay, so no active project. No. Okay, we'll do a new project. We'll call this project, I don't know, SW06. Okay, so Game Boy says I got the key. You got the key? Is it looking? Is it a number key? Okay, so we're gonna import the file. This one. Can you give me a shout out? So shout out to NGIIER. Hello. Welcome to the stream. What is up? Okay, so import that thing. The flag? Oh, the flag. Okay. Yeah, you got the flag. Okay, we're gonna load in this file. I'm gonna analyze it. Okay, so we're looking at this thing in the Ghidra program now. Okay, that doesn't help. Ooh, what the heck? Put that away. Okay, so the main function is over here. Oh, we've got references too. So the thing is that I do not know how to use Ghidra very well. I wish I did. Wait. Justo? Okay. So we got our la flag, qual la flag. We got our headers. Left side, you have trees, you can look at the functions. Oh, that's true, that's true. So we can go over to the functions, and we can load in the main function over here. So this is the main function. You don't need to scroll to find it. Can we isolate this into a window or something? We got the local variables here. And do these load in? I guess they don't. Okay, we can adjust the views over here. Window. I want to take a look at disassembled view. Decompiled view. Okay. Hold on. Main function, decompiled view. This is what I want. Can I make this bigger? Properties. Okay, we can make this bigger. So we'll make it 18-point font. Okay, this is much easier to look at now. I was writing it using memcomp to check the flag and based on that make a decision. Okay, so what we're for, if local something something equals hex E, put this thing, but we don't know what this thing is. So int variable size. Look at ivar1. Hold on. Can we also look at the other window? Listing, decompile. Can we detach this? It'd be nice if we could detach this. I guess we're not allowed to detach it. Okay, ivar1, go down. Where is this referenced? ivar1 equals memory comparison. Oh, okay. Try right-clicking to see if it pops out. Right-click. Is this locked? I think we might be able to change this window to something else. So can we go to Window and then do listing? No. So hex E is the size of the flag. The size of the flag is hex E, okay. Local 118 flag hex E. Local 118 is referenced here. But what is local 118? So byte local 118 is equal to, I guess we should be looking for some justo. Justo is that the flag or the thing that we need to test? I don't know. It's not justo. put a breakpoint at memory comparison and then take a look at the value of RDI. So the problem, okay, let's give it a try. So PDF. So memory comparison is here. That's the call. So the next instruction is here. Set the breakpoint. Search next to it. So where does it say Justo again? Okay, so we set that breakpoint there. I don't think we've got any other breakpoints right now. No, we don't. Actually, no, we've got this one here. Let's unset that. Run the program. What is the flag? Okay. So it doesn't get there in the normal execution. So I think we need to pay attention to the comparisons here. So keyword comparison keyword with 0. So 120 hex. Where is it defined? Go to Ghidra search. Well, we got Ghidra over here. Okay. Let's pull this all down. Search menu. So search menu, search memory. So we're looking for a string. Okay. I mean, we found it. Here it is, Justo. Can I make this bigger? So show references. What are we doing? Okay, so Brew asks, do they need to have the flag as a string? So the flag is, I'm not exactly sure how the flag is loaded in. Savano, qual la flag? We got some functions. Okay, I think we can get hints. We can get hints in the in these challenges. So I'm pretty sure there's a hint here. It says hint minus 0 points. Hint 1 is, do you really want to unlock the hint? Yes, we do want to unlock the hint. Okay, so it says what? It says import for the program something something. Let's translate that. Give me the hint. The program input is Zord with a key. The program input is Zord with a key. Okay, well, I mean, so where's the, I mean, we could, I think I saw an XOR operation. So the XOR operation is where? XOR. Well, I mean, XOR EAX isn't really a thing. That was the test. The test was the XOR operation? Okay, so we have XOR EDX EAX. So move. Let me just check to see if there are any other XOR operations. You know what? You know what's funny? I thought it would be. I thought all of these challenges would be kind of easy, but I guessed wrong. Okay, so XOR EDX with EAX. Before that happens, we move the bytes from EAX into byte RAX. So EDX at this point is going to be the XOR key. So let's see if we can do this test over here. So set the breakpoint here, and we'll unset the breakpoint for those other places. So we've got a couple of breakpoints. I don't think we need this one. And I don't think we need this one right now. Brennan Lavelle, what time do you... Oh, are you talking about what time I stop stream? I usually stop stream in about 20 minutes or so. So we got 21 minutes on the clock. When that time is over, I should be wrapping up the stream. Okay, so let's run the thing. So it's actually the XOR operation is going to decrypt the flag. So if it's going to decrypt the flag, then I can't draw hands has just subscribed on YouTube. Thank you very much. I can't draw hands. Let's give you a fun video redeem. How about some, what do we got? Some all the things. Drink all the booze and hack all the things. Yeah, so if you're interested in what we're going to be doing for the next stream, we've got a subreddit over at HackerFrogs. Here it is. Will you be live tomorrow or no? No, we stream on Monday, Wednesday, Friday, and we do have the schedule for the next week. So next week we're going to be streaming on Monday, September 15th, and then on the Wednesday, and then on the Friday. So if you want, you can take a look at the schedule over here. Okay. So what are... Load into RSI object flag, and I'm assuming that there's some sort of XOR operation on it. Okay, so let me take a look at the challenge. So let's see. The program input is XORed with a key. Does that link put Bitcoin miner on my device by any chance? Well, I mean, it depends on how much you trust Reddit.com. So if you don't trust Reddit.com, don't click on the link. There is that object.key. So if we go back over here, there was the object dump command that we did with the other binary. So this is 06. These are all of the sections. The program input is XORed with a key. I mean, if the input is XORed with a key, then we need to figure out what it's compared against. And then we also need to get the key. I'm very surprised that the difficulty of the challenge is ramped up this much all of a sudden. So hint, we already have this hint. Okay. So the description of the challenge says this. What other functions are listed in Ghidra? So I mean, there might be a function. I mean, the functions in Ghidra, we should be able to see them in Radare 2 as well. Okay. So all function list, we've got a bunch of unlabeled functions. There's also fgets, memset, printf, string length puts, entry 0. No other functions that look really suspicious. Pick one with a lot of info in it. The memory comparison one over here, I mean, I guess we could take a look at this. The FCN ones. The FC1N ones, this has a lot of stuff going on. I have no idea what this actually is. The number is big, so I guess we could check it out. The numbers here are even bigger. Okay. Wait, the number here is even bigger than the other ones. But I don't know if these are the things that we need to pay attention to. I mean, we could take a look at the functions. You want to print this many lines? I guess we could. I mean, most of this is nothing. Yeah. You know what? I think I'll come back to this. I'll do some more research on it. But let's maybe we'll do like an easier challenge just so we can finish off the night on a high note. I'll come back to this. I'll probably, yeah. Okay, so strings 3, I need to get back to this. So we did stack 1, we did dynamic 1. How about dynamic 2? Let's try dynamic 2. Okay, so this is the dynamic 2 challenge at software 9. Let's do a translation. So the binary is identical to... Why don't we ask some AI? I mean, the AI isn't guaranteed to be able to give us a good answer either, but I'll come back to it. I might ask the AI off stream, because just asking AI for answers over and over again on stream, it doesn't look very good. This binary is identical to dynamic 1, but this time it's compiled statically. Compiled statically, okay? The ltrace command is therefore no longer available, as it only works dynamically with linked libraries. Try using the strace command, a tool that allows you to trace the system calls executed by a binary. Okay, so... Are there any write-ups for that strings 3 challenge? Maybe. Maybe. Well, I mean, if I'm stuck for a really long time, I do look at the write-ups, just so that I can move on with my life. But let's try this dynamic 2 challenge. Okay, so where are we? Alright, so we got SW09. And they're telling us to use the... Let's get out of here. They're telling us to use the strace command. So we first need to make this executable, SW09. Then we need to run SW09. It says executing flag. Executing open flag. Alright, well, they said use the strace function. So the strace command. So let's see, Zlik, I'm not too sure how to pronounce your name. ZSEC, what do you suggest is the best way to set up test environments? I often find setting up targets and specifically ADs exhausting. Any alternatives or easy setup labs out there? Probably wants input as you run it. Probably. Let's see. Gameboy says file link. Gameboy, if you want to participate in these challenges, you can make an account over at OLIcyber.it. So strace. There's also ltrace. So let's see. We'll run the binary and we'll give it test flag. Executing flag. So let's try running strace on this. Okay, so it's the... What is going on here? So it runs uname. It runs readlink. It runs mprotect, fstat, and write. So write is going to write stuff to the terminal. Executing flag. The flag is right here. So it says no such file or directory. It tries to... That's interesting. So the strace gives you some clues as to how you're supposed to, complete the challenge. Okay, that's done. All right, submit the flag. Valid flag. So I guess we can, let's see, well, strings 3, yeah, we weren't able to solve this, but we were able to solve dynamic. Dynamic 2. Thank you very much, Christian Wickman. Let me know how to pronounce your name. Thank you. Thank you very much, Christian. And welcome to the stream. Let's give you a fun Hack the Planet. It's what we try to do.
Hack the planet! Hack the planet! Shut up and get in.
Okay, let's put on some new music. Running out of music to play, but we don't have to play it for too long. Okay, let's play some... Let's replay Baba Is You. MC25 says, double check the link that you posted. The JWT didn't have any major info in it. Double check the link you posted. JWT didn't have any major info in it. Which link are we talking about? Let me know which link you're referring to, MC25. Okay, so the one you sent Game Boy had an auth in it. Really? Oh, interesting. Oh, it had my user ID. Oh, okay. I mean, this is something we should take note of. Thank you. Thank you for letting me know about that. Concept, method of solve. So the concept in this case is use strace to see what... So the difference, what is the major difference between strace and ltrace? So ltrace is for libraries. What is the difference between the Linux strace and ltrace commands? Okay, so the one sentence summary is strace traces system calls, the program talking to the kernel, while ltrace traces library calls, the program talking with shared libraries. So when you run a file on it, it will say if it's static or dynamically linked. So let's see. When you run file on it, oh, okay. So let's run file on SW09. So statically linked. So statically linked versus dynamically linked. So dynamically linked means it uses a bunch of DLLs, or wait. strace equals static versus, yeah, okay. All right, so let's complete the walkthrough. Okay, we got these. URL is here. Use strace to see what system calls the binary references during its operation. Method of solve. Use the strace command. So we just need to run this. Strace SW09 note that there is the flag in the strace command output. Okay, and that is done. Okay, so let's, we actually did a lot today. We did a lot of these challenges. Most of them were pretty easy. Then we came across one that wasn't so easy. I think we might be able to do one more. Let's give it a try. Okay, so dynamic 1, dynamic 2, dynamic 3. Dynamic 3, not... Let's give it a try. So software 10, dynamic 3. Let's set this up. Okay, we've got the file. Okay. So let's see if we can speedrun this. If we run into any speed bumps at all, we're probably not going to be able to finish this before we run out of time. But you know what? Sometimes that's okay. Okay, method of solve. Okay, let's grab that link. So everybody, if you want to give this a try yourself, this is where you want to get your file. Okay, and in the challenge, they've got this description. We will translate the description over here. The binary calls the access flag function. However, as is often the case, binaries make many calls to other functions, so it'll be helpful to filter them somehow. The ltrace command provides the -e option, which allows you to filter the functions called. Filter the functions called. Well, I guess we'll figure it out when we run the thing. Okay, let's do that. Download the file. And then make it executable. Okay, so we're just gonna ltrace. So ltrace, we can run the file command on this as well. So this is dynamically linked, which means that we can use ltrace on it. If it was statically linked, then we would run strace on it, just like what our good friend MC25 said. Okay, so let's go ahead and run ltrace. Wow. Wow. Okay, well, you can use strace on dynamic ones as well and compare the information. Open at this is not your flag. Wait, you know what? Let's see if we can cheese this a little bit. So grep out. Grep out not your flag, or not your. Why didn't it grep out? That's funny. Anyways, let's do what the challenge suggests for us. So the suggestion is to use -e on ltrace. So ltrace -e, few arguments. Few arguments. So how are we supposed to do this? Are we supposed to filter this is not your flag? something like this. Dash E is to exclude. Ltrace E. So let's see. Let me see an example. Ltrace E. Ltrace dash E. Okay. We can also do TLDR on Ltrace. Trace calls to malloc and free, omit those done by libc. Okay, back now, I'm behind. You're not really behind. We only tried to do a reverse engineering challenge that we spent like a couple hours not finishing. Okay, so trace calls to malloc and free, omit those lines by libc. So path to program, open at, read only, this is not your flag, over and over again. So how do we run this thing? I'll try asking the AI, because you know what? I don't know what I'm doing with the Ltrace. Okay. We want to run Ltrace, but use the -E flag to filter on this output. The output is this. Okay, to use Ltrace with the E flag to filter and only show open at calls, you would use Ltrace-E open at your binary. So E open at tells Ltrace to only trace calls to open at system call library function. This will filter out all other library calls and show only open at operations. Okay, let's give it a try. There's nothing. There's nothing. There's nothing. Okay, let's take a look at the challenge. So the binary calls the access flag function. However, as is often the case, binaries often make calls to other functions, so it's helpful to be able to filter them somehow. Ltrace command provides the -E option, which allows you to filter the functions called. So here's the problem. Also try to provide input with it. I mean, this filtered everything. Open at. So open at or open. Maybe just filter open. So if we filter open at, then it filters everything. And we don't want to filter everything. So what are we supposed to be doing here? So Game Boy, I'm not too sure what challenge you're referring to right now. Are you talking about the challenge we're doing right now, or are you talking about the other challenge? Goal isn't to find it with strings, is to teach ltrace. So this is not your flag, this is not your flag. So the filter is a qualifying expression which modifies the library calls. Usage examples and the syntax description appear below in the sections filter specifications and filter expressions. Okay, so binaries make many calls to other functions. So this is not your flag gets referenced a bunch. But you know what? We can't. I don't think we're going to be able to finish this challenge because we've run out of time. You know what? Let me get a hint. Maybe we can finish this challenge. Okay. There are no hints. There are no hints here. So maybe I can see it. Maybe I can get open Ghidra. Trace library calls. How does ltrace work? No. I'm trying to use ltrace. Okay, ltrace, Linux ltrace command with practical examples. Okay, so let's see, -e. They don't even mention -e in here. All right, everybody, it's been a lot of fun. We're gonna be. Who should we raid into? So on Twitch, we like to do what are called raids. We redirect viewers to different channels, and there's a list of InfoSec streamers that stream. There's nobody online right now. I think the InfoSec streamers list might be a little bit broken right now. But we can also raid out to other cool people on Twitch. Let me just get a list of who's online right now. Okay, so we got, science streams. So the science stream is online. Science streams is all about, whoa, there's CyberKaida. CyberKaida is also doing low-level stuff. Let's go ahead and, we'll show what CyberKaida is doing. I haven't seen CyberKaida online in a long time. But CyberKaida is a VTuber who does low-level stuff. I think they're working with Ghidra right now. Let's take a look. Okay, CyberKaida is doing Ghidra development. Okay, so if you have any questions about low-level stuff, maybe you can ask CyberKaida to do the stuff that we were doing. You can always go ahead and ask, but let's start that raid. So it's a good opportunity to learn about some new InfoSec streamers. So let's see, raid CyberKaida, and I hope everybody has a great weekend. We will be back after the weekend on Monday. But yeah, everybody have a great weekend. We will be back on Monday. We'll be doing all sorts of great Linux stuff. But when you arrive on Cybercat's channel, give this message right here. So OSFrog, hip hop hack OSFrog. All right, everybody, have yourselves a great evening. Jig000, you can have fun with Cyberkita. Go ahead and ask some questions about Ghidra and stuff. But give this message when you arrive over there. We'll see you next time. HackerFrogs rating in 3, 2, 1. HackerFrogs out.